Right, Michael. Sir, ma'am, presenter enable பண்ண முடியுமான்னு check பண்ணுங்களேன் sir. HOD sir. Doreen ma'am unable to unmute her mic sir. So kindly check the ma'am right sir. If possible, kindly make ma'am as a presenter sir.
இல்ல அவங்க தான் மேடம் பார்த்தணும். இங்க வந்து அவங்க தான் அன்மியூட் பண்ணணும். அவங்கள அன்மியூட் பண்ண சொல்லுங்க மேடம். மேம் ஆடியபிளா இருக்கா வாய்ஸ்?
Sir, voice is breaking.
மேடம் தான் மேடம் இது பண்ணணும்.
Yes, ma'am. Welcome you, ma'am. Doreen ma'am, welcome you. Yes, ma'am.
Welcome, ma'am. Able to hear me?
எஸ் மேடம். குட் ஈவினிங் மேடம்.
Good evening, sir.
Yes, ma'am. Now unable to unmute yourself, right, ma'am? Able to hear my voice, ma'am?
Yes.
Ma'am, voice not audible. Doreen ma'am?
Is my voice audible now?
எஸ் மேடம். ஆடியபிள்.
Ma'am, voice not audible, ma'am.
மேம் ஆடியபிள்.
Yes, ma'am.
Okay.
Yes, ma'am. Now it is okay. Yes,
Okay.
ma'am.
Okay.
Yes, ma'am. Welcome you for the today Atal FDP, ma'am. Yes, ma'am. We will wait for a few more minutes. Let others can join. So totally around approximately 150 participants were there. As of now, 76 joined, ma'am. We will wait for 5 more minutes.
மேடம் ஸ்டார்ட் பண்ணலாம் மேடம். எம்படி மேடம்? எம்படி மேடம்?
Yes, sir.
ஸ்டார்ட் பண்ணலாம்.
Yes, sir. Yes, sir. Dear participants, I welcome you all for the today Atal FDP program, 6 days online FDP program on advanced data science and NLP, elevate our research and H index. So today we are in day 3, session 5, introduction to machine learning, foundations and applications, going to handle by Dr. Doreen Robin, data scientist. I invite Ms. G. Sandhya ma'am, assistant professor, senior grade, Department of Information technology to deliver, to provide a brief introduction about the today resource person. Yes, ma'am. Welcome you, ma'am. G. Sandhya, ma'am.
Yes. Yes, ma'am. Am I audible, ma'am?
Yeah, yes, ma'am. You audible. You carry on.
Good evening, everyone. It is my pleasure to introduce today's expert speaker, Dr. Doreen Robin, a distinguished data scientist, keynote speaker, and trainer in the fields of machine learning, deep learning, big data analytics, and more. Dr. Doreen Robin is currently the founder and director of Computational Intelligence Research Foundation, where she leads innovative research in information and communication technology. She holds a PhD in computer science and engineering from Anna University, Chennai, and her research interests include parallel and distributed computing, grid computing, cloud computing, and big data analytics. Dr. Doreen Robin's academic journey is distinguished by her roles as a professor at Loyola ICAM College of Engineering and Technology and as an assistant professor at Sri Venkateswara College of Engineering, Chennai. She has published over 30 papers in prestigious national and international journals and conferences. In addition to her academic and research roles, Dr. Doreen Robin is also a dedicated trainer, having trained over 4,000 plus staff on how to teach online during the pandemic. She has also worked as principal and administrator in various educational institutions and is actively involved in Christian media and youth counseling. We are incredibly fortunate to have Dr. Doreen Robin with us today to share her profound knowledge and experience. I welcome Dr. Doreen Robin to lead us through this enlightening session. Welcome, ma'am.
Thank you, Sandhya ma'am, for the good introduction. Good evening, all. All right. I'd like to thank the entire management of SRM Valliyamai, especially Shanbagavadi ma'am, Narayanan sir. I've been closely associated with SRM for the past 6 years, I suppose, right? So thank you for this opportunity. I think this is the third Atal FTP of this session. I'm handling it, right? So thank you all. How are you all doing today? How are you all doing today? Can I have the answers on chat? I think you can, people, can they use chat? All the faculties, can they use chat? Or on question answers? I could not see chat. You're able to access chat? How are you all doing today? Or I think you can have reactions, right? Can you click on any reactions? Yes, no? I can see Banu, Prakash, Professor giving a thumbs up. Yes, Sandhya ma'am giving a thumbs up. Others? Only two. We have 93 people here. All right. Yeah, thank you, Jay Chandran, Professor Munir Ali. All right. Like there's always possibilities, right? So happy to hear that you're all great. And add that to the session. That's an evening session. Am I audible? A thumbs up, please, if I'm audible. Yes?
Yes, ma'am.
Yeah, thank you so much. So you had been dealing with the different topics, and for me, this is the third session for the day, right? And we have been training for 30 hours for almost 300 students of cybersecurity. Each is 2 hours per day. So today is my day 10. Because of climate, we are online and just completed. Like it was, it is little difficult, but still, I love sharing and teaching. Right, that's one of my passion of it. So today, let's see into what are the machine learning fundamentals. All right. I hope my screen is seen to you. Yes. Can you give me a thumbs up? Yeah, I can see a few thumbs ups. All right. And today we are going to see for the next 1.5 hours about introduction to machine learning foundations and applications. All right. And what is machine learning from your perspective? Anybody, can they unmute and speak, or they use chat? Which is possible, ma'am?
Yes, ma'am. They can unmute and then they can freely speak with you also. Yes, ma'am. And chat box is also enabled to them. They can use both also.
Maybe chat box I'm not able to see. I'm able to see question and answers, but chat box is little difficult. I don't know. It shows an
Then
error.
participants, you can interact with the resource person.
Yeah. All right. So what is from your perspective? All right. Machine learning. You can put on the chat, you can unmute and speak. You could be right, you could be wrong. All right. This is a beautiful topic on FTP, right? On advanced data science. I think the first FTP that I handled for this session in winter is for RV institutions at Bangalore. They have taken data science with sustainable development goals, right? And again, it is the second FTP was with AR/VR, and now this is with machine learning, right? A deeper part of it. All right. So let's play a game. I'll show you an image. I want you to interact. All right. And I want you to find what is the error on that image. And this is not an error. You know about me already. They have shared about me. I'm basically a data scientist, keynote speaker, machine learning and deep learning trainer. This is my mail ID. If you wish, you can get connected, maybe for future. What is the mistake in this? Can you unmute and speak, please? What's the mistake? Can you spot the mistake? So I want to give 15 seconds.
Yellow balloon is the problem, ma'am.
Yellow balloon is the problem. What is the problem with yellow balloon?
Its size may be small.
Its size is small. Okay. Good try.
It is not in his hand.
Okay, it's not in the hand of anyone. Thank you, sir. Good try, but not the right answer. All right, anyone? Yes, 15 seconds is over. Anyone would like to? Those who can keep.
Ma'am, rainbow is there, but the sky is not blue.
The rainbow is there, sky is not blue.
It's on the white background.
Hello, ma'am.
Ma'am, are you there, ma'am? Shanba?
Yeah, it's audible, ma'am.
Yes. I think ma'am is having some network issue.
All right. I'm sorry, there was some mistakes, and that is what I'm not able to. There was ma'am who was. Yeah, yes, ma'am. Can you hear me now? Can you all hear me?
Yeah, yes, ma'am.
Yes, ma'am, we are hearing you, ma'am.
I always say expect the unexpected, right? And that's what this too. Yes, can you tell? One ma'am was answering. Is it Usha ma'am, Dr. Usha
Yeah.
ma'am?
Yes, ma'am.
You said?
Rainbow is there, sky is not blue, ma'am.
Okay, okay.
Background.
Ma'am, excuse me, ma'am.
Tell me, ma'am. Uma, ma'am.
Yeah, ma'am. I have noticed that pink color balloon is an odd one.
Pink
It is
color.
based on the Vib GR.
Okay, okay.
Excuse me, ma'am.
Yes, ma'am.
Ma'am, actually the rainbow is from WebGR, right? Violet color first and last one is red.
Yes,
Yeah,
that's
it's arrangement.
so the right
Arrangement.
answer. Yeah, the right answer goes to Nitya, ma'am. Right, the right answer goes to Nitya, ma'am. See, in this picture, every one of us were trying to figure out different mistakes. I do accept it's a mistake, but the fact, right? More importantly, the fact is that the color of the rainbow starts from violet, indigo, blue, green, yellow, orange, and red. All right. And you see the first color is, what is the first color here? What's the first color? It's indigo and then violet. So how the rainbow should come? That's the mistake. Able to get it? Do you agree with me, professors? Yes? Many a times. Do you agree with me? Yes, no? All right. It's okay. Everybody, we have got some time to try it. The reason behind what I'm trying to say is that in data science, right, we need to find, if we know the facts, we'll be able to know the patterns and we'll be able to go in to figure out what is the insights that we really want to get into. All right. I hope my voice is audible, right? Do you agree with my question? If you agree with my answer, can you give me a thumbs up, please? Yes, if you agree with my answer. The answer is wrong, right? Yes or no? All right. So this is what is very important in data science, knowing the facts. Let's try one more. What's wrong with this picture? I hope you're able to see my screen. What's wrong with this picture? You can unmute and speak. I give you 15 seconds. Please feel free to unmute and speak. Please keep your cameras on to the possible extent. Yes, please. 15 seconds is done. Can any of us say what is the mistakes in this? Yes or no? Am I audible or not? Am I audible? Hello?
Yes,
You're
ma'am.
audible,
Yes, ma'am.
ma'am.
You are audible, ma'am. Yes, ma'am.
Because I'm not getting any response.
Yes, ma'am.
What is the mistake in this picture? Anybody? Any tries? Fast. Try to think of the facts and then apply. What do you see on the picture? What do you see on the picture?
Dear
Can-
participants, kindly interact with the resource person. Then only ma'am can move forward. Okay. So ma'am session usually starts with some simple questions and then ma'am will go further. Okay. So kindly provide your interactions with the resource person, please.
You could be
Ma'am,
right.
the bush is containing full of that cherries like fruit, but one fruit is odd from there.
One fruit is odd. Okay. Thank you. Then what it is collecting? It is collecting strawberries. Do you like it is strawberry? Any other one more? I'll give chances for two more people to give response. One professor already gave two more. Kindly give any response. You're 114. That's really a good number. Yeah. Yes, tell me. What do you see? The fruit is strawberry, right? Anyone? Please do answer, please. No more? Okay. You see, it is strawberry. Remember everybody would have studied in a middle school. Strawberry do not grow on bushes. All right. Strawberry grows like this. Strawberry does not grow on bushes. So that's the wrong in this picture. Why I've shared these two pictures, you may wonder we are going to see about machine learning, its fundamentals and applications. All right. But this is one such trigger factor we need to know on data science, all right, without knowing facts, because systems can work with lakhs and lakhs of data, right? Some of you would be data work with lot of machine learning algorithms, right? You can develop on your own, you can use Scikit, you can get codings or content from GitHub, Kaggle, you have your students working on with that, so much and so more. But importantly, what machine learning can do, it can process, you and me cannot process 10 lakhs of data in microseconds. Do you agree with me? But a machine learning algorithm can access 10 lakhs of data in microseconds. At our research organization, one project we worked with the drought analysis. The data was almost 1.2 crores of data, but it worked within microseconds and we got the results out of it. All right. So this is what the capable of machine is. One thing the machine is not capable of is called it does not have common sense. That is why you and me we have. So without knowing facts, we know data science or machine learning or deep learning, it's all the umbrella word that I will speak about with clear little distinctions about it. But everything learns with the patterns of the data. Learning the patterns of data. When you take data science as an interdisciplinary field that uses scientific methods, it processes different algorithms. All right, it uses systems to extract knowledge. That is what it is. From the system, we need to extract knowledge, find patterns, and then we have to recommend things, right? It insights from structured and unstructured data and applying knowledge into actionable insights from data. All right, how many of you watch YouTube? Right? Do you watch love? Do you watch YouTube videos? If so, click recent or like. Yeah, we also. When you see a YouTube video onto the right, do you see relative videos onto the same type? Yes, no?
Yes, 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 yes.
Yes, ma'am.
So why do you think, say for example, you are going to teach about DevOps, like development and operation. Like I know all the faculties, we would have not learned those subjects when we were in our college. Right? What we are teaching is something different from what we have in our college, right? But we learn, right? Sometimes one of our resources can be YouTube. When you see a video for DevOps on YouTube, maybe Ensemble or Jenkins or whatever it is, you'll be seeing relative videos onto the right. The machine that runs behind, the machine learning algorithm that runs behind it is called as the recommendation system. How this recommendation system works, right? Every user, when you click on to the videos, you find it is interesting, then you watch over the video, then you go to the next chain of video. It finds the data patterns and builds the blocking, or it builds the chaining of videos. That is what you get it onto the right. Maybe you see a video on DevOps. For example, I'm telling about DevOps this month. You see after 6 months, the recommendation will not be the same because YouTube has its inbuilt machine learning algorithm. All right. How many of you, which is one of the, we buy a lot of products in online, right? Which applications you use the most? Either you can unmute and speak, or you can put the answers on the chat. I don't know, for me, chat is not working. You can put it on QA also. I'll be able to find answers from that. What is the most, the app that you use frequently to buy some things through online? Maybe for home or something like that. Amazon. Thank you, Professor J. Chandran. It's Amazon. Others?
Flipkart, ma'am.
Flipkart. Okay.
Flipkart. Yes.
Amazon. Yes. Thank you. All right. When you buy, say for example, I'm going to take Amazon. Like maybe the recent product, I know if you want to buy a mobile phone, for example, when you search for a mobile phone, or whether you're able to see beneath customer who viewed this product has also viewed these products. Have you seen it? Yes, no? Let's be little.
Yes, ma'am. Yes, ma'am.
Yeah.
Yes, ma'am.
How does that happen? How does that happen? The reason behind, there is a machine learning algorithm that runs on Amazon that takes the patterns, how people search for what is the specification, what is the RAM, what is the brand, what is the pricing, and every search get built. That is called as a recommendation system. Right? So what recommendation system, it from the previous user's experience, it tries to recommend to the new user, this could be also a better product for you to see. When you go to shop, they say, if you're going to buy a shop, for example, if you want to buy a sari for 2000 rupees, right? You ask for a model, then the shopkeeper will come, ma'am, see, these are the models available, because there's a human present on a physical shop, but you're not having any human present, but the number of interactions. Can any one of you Google and tell me how many products does Amazon sells per day? Yes, quick, please. I want answers on QA, or you can unmute and speak. How many products Amazon sells
Ma'am,
per
it's approximately about 6 million items sold per day, ma'am.
approximately, yeah. The
In
reason,
India.
yeah, products alone 600 million products. Amazon sells over 12 million items per day. All right. This is based on 2023. Still, we have not seen about 2024. All right. See the amount, the number of items is huge. Yes. Do you agree with me? You cannot employ people. See, this is the effectiveness of machine learning. All right, this is the effectiveness of every interaction, every click that you do, there's an algorithm that captures your data behind, right? So now there are many Python libraries available to develop your data science, right? First, we need to do on the visualization. The packages are called NumPy, which stands for numerical Python, Pandas for data analysis and visualization, Matplotlib is for visualization, right? So for analysis, it is Pandas. For numerical Python, right? How many of you have, we are all mostly, you may be computer science professionals, sorry, engineering professionals, right? And how many of you are engineers? You're working in engineering college? Yes, most of you. Yeah, I can see. Yes, I can see Sam King. All right. Yes, Sendil Kumaran sir, Venkateshan sir. Others? Yeah. So, you know, we should have learned a lot of difficult mathematical applications, right? All those things you can use it using NumPy. Right, we import NumPy as NP, which stands for numerical Python. See, what are the applications that you can use? You can work with quantum computing. You can use with statistical computing. If you are an ECE professional, you can work with sometimes. See, at CIRF, we work with 4 pillars. One is research, development, education, and training. In training, students come for internships. You know, mechanical students come, ECE students come, MSc physics students come, chemistry students come. I teach them all basically data science because it is going to be one of the mandatory skill from 2020 into any job. See, signal processing, they can work, image processing, graph networks, astronomy, cognitive, right? Architecture and engineering, geographic process, geoscience, chemistry, mathematical analysis. Can you see bioinformatics? And when you see SkyPy, right, you can see what are the difficult components, right? Everything it has got its own inbuilding. You can see like eigenvectors, sorry, you can see eigenvectors, right? Integration, differentiation, all its statistics, everything could be applied using this. How many of you have worked with NumPy? Or is it new? I don't know. How many of you work with NumPy? Yes, I can see Sendil Kumar sir, Dr. Venkateshan sir. All right. All right, Uma Geshwari ma'am, right? Maybe some for some you would have already worked, for some it will be new, right? So what is machine learning and deep learning? right? Both machine learning, a part of machine learning is a part of AI, a subset of AI is machine learning, subset of machine learning is deep learning. All right. So both machine learning and deep learning, they discover patterns in data, but they involve dramatically different techniques. So that's what I always say. Data science is such that you are figuring out patterns of data. How many of you have got some close friends in your college, now in your workplace? Do you have close friends? Or you don't have friends at all? If you have got good friends, right? Click raise hands, right? Yeah. Okay, like Usha ma'am, most of you, Nitya ma'am, Jay Chandran sir, right? Gopinath sir, right? I hope I'm spelling it right. Yeah. Ashwin Kumar sir, Shiva, everybody. You remember yourself. Maybe they are college students, your friends, or workplace, their friends, I don't know. Remember our first interaction, right? Even when we go to college, when we have gone to college, right? First day, we smile at everyone, all the friends in our college, right? When going back to memories of being a student, right? But when you come to second year, then we have little gangs that we have, right? When we go to third year, it becomes even more stronger. When it becomes final year, we know who are our close friends. Even by the end of first year, we know who are our close friends. We try to find whose behavior matches with our behavior or only our friends. It takes time for us to experiment, to find out, to discover, and whose wavelength will work out with us, and then we become friends. It takes time. Yes or no? Do you agree with me? Yes. So we spend time with them, and then
Yes, ma'am.
who helps us in time of need? Then here we are trying to discovering the behavioral patterns, and then we become friends. All right. Same thing works out in data science, but it is working in huge volumes of data, discovering the data patterns. All right. It discovers the data patterns. All right. So when you see both looks the same, machine learning and deep learning, both discovers patterns of data, but the way they find patterns of data is different. All these things, both machine learning and deep learning, are both forms of artificial intelligence, right? So when you see deep learning, it's a specific, and that's what I say. The entire shell is artificial intelligence. A subset of AI is machine learning. Subset of machine learning is deep learning. All right. So today we are going to see about machine learning by and large, but let's know what's the difference between machine learning and deep learning. See, for example, when you see machine learning, they both start with training data and testing data. That's the first step. Then they go to a model, and then they go to the optimization. We are all professors, right? We are all professors in engineering or any college, right? So what it generally does, right? What it generally does, if you see to it, um, when students are coming to a college, first we give them different internals. How many internal exam do you conduct in your college? One or two?
3, ma'am.
Ah,
3, ma'am.
three internals. By the end of third internal, you will know who will pass in the end semester, who will fail in the end semester, yes or no? We'll tell the
Yes,
students.
ma'am.
Yes, ma'am.
We know because we know them. We are the one who train them right from first internal, second internal, third internal, and we know we keep special classes. We ask the students to stay back or something or the other. We know who are the students who maybe fails, right? Because of our experience. That is a training set. But in the examination, what they do, right? In training, you know the results, but in the testing, you'll not know the resultant data. So testing is the testing phase, or the data is where they appear for their final examination. And more than our expectation, many students, they pass on the final exam too, right? So, and then they go through, see, every year, do you teach the same method or you keep changing the methodology of teaching?
Changing the methodology.
Yes, thank you, Jayachandran sir. You're some active professor, right? We keep changing. We know which student, like some batches, but I don't know. I always tell my students, right, in all my 10 years of teaching, I never say you are the worst batch. Every batch, I'll say you are the best than the previous batch. You are best than the previous batch, right? And students will tell me sometimes, many a times, professor says, you are the worst batch. Why, ma'am, you always say to that? Because I think every batch is best because I am changing myself the way that I teach. Like for example, I'm handling now we are teaching for all PG students cybersecurity 30 hours course as prescribed by UGC for MA English, for psychology, for FSND, like MCOM, different. If you see on my LinkedIn page, you'll be able to figure it out. This is the third time I'm handling the session. Like already we have handled, like had trained 600 students, like 2022, 23, yeah, 24, we are doing it, right? But my content is not the same because the number of cyber crimes and the methodology of cyber crimes and the cases are different, and every time I handle is different. Maybe the core is the same, but the way I handle is different. So we know how the students are, and we are trying to optimize ourselves and present the best to the students, right? As faculties, teaching is such a noble job that we try to build the next generation. All right, it cannot be taken as granted because you all want to learn something new. That is what, even after a day's work, you're all joined to this FTP, like 135 people into the session. Even for me, it's like taking 4 periods, right? Continuous 4 hours, right? 2 hours and then a break, and then 2 hours for addressing 300 students. And back, this is third session because I always desire to teach somebody, right? Or to learn what I know, others should know. All right, if they are interested. So when I take artificial intelligence, machine is able to carry out work in a smarter way. Can you tell any machines that is able to work in a smarter way that we have at home or wherever we travel? Any simple examples anybody can say? Those who have not answered can answer. We have so many people here today. Yes. Can anyone say? Yes, ma'am.
Robots can walk.
Robots. A simple example. How many of you have washing machine at home? We have washing machine at what it does, it's machine enabled, right? You tell this is cotton, this is what I need, and then it does the job what we do. Yes or no? Very, very, very simple example of artificial intelligence. You take a dishwasher, microwave, right? Very simplest example of artificial, where the machine is able to carry your task on its own in a smarter way. All right. Then the subset of machine AI, artificial intelligence, is machine learning. What is machine learning? It allows the machine to give access to data, and they learn themselves and explore for themselves, right? So the machine should be given access. You know about Alexa, Siri, Google Assistant. All right. How Google Assistant, Siri, and all works? You have used it, Alexa? Yes. Yes, ma'am.
Yes, I used it.
We try to give an instruction, right? Right? We try to give an instruction. Alexa, do this. Alexa, do that. Alexa, do this. All right. These are example of weaker AI, but still, it is it's a subset that we give data and they learn themselves and they do it, right? And the major clusters of machine learning is called classification, clustering, and regression, right? What is classification, right? What is classification in the sense, for example, when I'm going to take a data set, right? And the best data set that you can take it is from the UCI machine learning repository. How many of you have used UCI machine learning repository? Can you click raise hands or any kind of reactions can you give if you have used? UCI machine learning repository? Yes, no? Either give me yes or no. All right. Yeah. Who said yes? Right. Okay, Adlin ma. All right. So UCI machine learning repository, here when you come into it, see here they give you enormous data set for you. Maybe some of your beginners in machine learning, some of your middle level, some of you could be even experts in machine learning. So this is one of the best data set that you can get for to do work with machine learning repository. Can you see here classification? At how many data sets? 672 data sets, right? Say, for example, I'm going to get Twitter geospatial data, and here they will give what are the tasks you can do with the data set. Here they've been giving all the 3 tasks can be done. That is what they say: classification, clustering, and regression. Right? So what is classification means? When you have something like a target, right? When you see the data set, you can see how many instances are there. When you have a target, then you find it, right? It is, you can work with classification. Say, for example, disease data sets, if I'm going to take, I'm just searching like disease. All right. See, I'm taking heart disease, right? So heart disease is there. This is 303 instances. And when I see to it, let me make it 15. Can you see there's something called target? Yes. Whenever I have a target, which means the diagnostics, maybe they are heart patient or not, taking these values. Very simple example I'm taking, right? So any data set that has a target, if you take students' data, right, with the marks, whether they are pass or fail, like if I take disease data set, then it shows like whether they have a particular disease or not. Can any one of you give me example data set that may have a target? Yes, please. Yes.
Ma'am, it's diabetic data set, maybe.
Diabetics data set, exactly correct. Yes, sir. Then your diabetes, if you an AC or your be fasting and post, how it is, and then we'll see to it whether you're diabetic or not. Then
COVID data set, ma'am.
COVID, exactly, whether you're COVID patient or not. And also an example, for every year you get so many applications for your college. How many students admitted, yes or no? That is also a target, yes? Other than disease, right? All right. You wait for a ticketing system on a railway station or a flight, whether you get the ticket or not. Maybe you get a ticket or you get an RAC or you get a waiting list. Yes. Any application that has a defined target, it comes under classification. All right. Any data set that has a target, then it comes under classification. All right. And next is clustering. Right. So what is clustering? Clustering is where you don't have a defined data set. All right. Clustering is something on machine learning. It does not have a defined data set. How many people go to malls? Mall. Do you go to mall? Yeah. For what purpose we all go to malls? What is the purpose?
To see a movie.
First, maybe the first target, maybe to see a movie, then others. Tell me. Only for movie you go to mall? And for what other you go?
Window shopping.
For shopping, then fast. Some audio I'm not able to hear it clearly. We go for food. Yes. Yes or no?
Yes, ma'am. Yes, ma'am.
And,
Yes, ma'am.
and then we go for movies. Then we go just for
Gaming,
free
ma'am. For gaming.
gaming. Then during summer we go for OCAC. Yes. Yes or no? Just to have some free time.
Yes,
All
ma'am.
right.
Yes,
Yeah.
ma'am.
Yes, ma'am.
Without
Yes.
even without any purpose, we go to mall and come. All right. So some goes for shopping, some goes for window shopping, some goes for free time, or just to spend some time. All right. And you don't have a predefined target. If I'm going to take this data set. When you don't have a predefined target, these kinds of application comes under clustering. All right, on machine learning. Able to understand? So classification, when you want to develop a classification model in machine learning, you need to have a defined data set, sorry, defined target. All right. If not, for clustering, we don't have a defined target, but it could be different clusters. So say for example, when students come into college, right? Some students do very well in the first semester. As they journey through, they come down. Generally, if you split a class, we can say above average, average, and below average. This is how we can split our students. So the members in the system will be shifting between above average, average, and below average. But we cannot say this is the predefined target, right? So, but where you take exam results, it's a predefined target, right? When you don't have a predefined target and the clusters may increase or decrease, or you don't have any target, it comes under clustering mechanism. For those kinds of data set, you need to use clustering mechanisms, right? On machine learning. The third methodology is called regression. What is regression? Which means it also has a target, but the values of the targets are continuously changing. All right. The values of the you know what is stock price? Is the stock price same or different?
Different, ma'am. Day by day is different.
Day by day, if it is different. When the target is changing, right? When the values are keep on changing, then you go on for applying regression. Right? You have a target, but the target is of changing values. If you buy a piece of land in 2020, and if you're going to buy the same piece of land in 2024, is the land value same or different?
Different.
Yeah, which is continuous, the gold price. Like the drugs that we take, the medicines. When the child is born, we give paracetamol. That's the target. But the values of the paracetamol is very less, right? 5 ml or even less than that. As the children grew up, all right, but the values keep changing. Yes or no? So for these kinds of application where there's a target and the target is continuous changed variables, then you need to use regression. All right. Is it clear till now? Yes or no?
Yes, ma'am.
Yes, ma'am. Clear, ma'am. Clear, ma'am.
Generally don't use much of slides, but then I ask people, like, this is about machine learning. The subset of machine learning is deep learning. I'll just give an introduction. We will not delve more into it, right? And it is similar to it, but it is more accurate in comparison with machine learning. But I had worked with maybe thousands and thousands of projects, all right. But what I see, people say the deep learning is more accurate than machine learning. Maybe some research scholars, I do guide some research scholars, I train them and they develop on their own. In some cases, I find machine learning is giving good accuracy than deep learning, in rarely in some cases. But what I tell, being a researcher on data science, I tell, it depends on the applications, right? For some applications, deep learning does not give good accuracy, whereas machine learning gives good accuracy. For some applications, deep learning gives good accuracy. It depends on application centric. That we should keep strong in our minds. All right. And so that's what I say. The entire thing is artificial intelligence. The subset of artificial intelligence is machine learning, and subset of machine learning is deep learning. That's from 1950s to 1980s. Then from 1980s to 2010, and now it is on deep learning. All right. So both machine learning and deep learning can handle both numeric and non-numeric. Numeric is regression. I said it, the values keep on changing, right? Non-numeric is yes or no, right? Which is classification problems, right? Which is of classification problems. Objects such as applications such as object detection and language translation. Deep learning gives more better fits than machine learning, right? So deep learning is machine learning. That's what I say. Deep learning is machine learning. All right. And what machine learning does? It parses the data, it learns from the data and applies what they have learned to make informed decisions, right? So first, whatever data you give, right? Whatever data you give, it tries to parse the data first, right? Once it parses the data, then only it tries to learn the patterns of the data and then learns from the data and makes informed decisions. I told you about the recommendation system. Do you remember? Right? I told you about the recommendation system. So on YouTube, on Amazon, and so much and so more, right? So here, when you see the very simple example of that is a YouTube next video that I told you, all right. Right, machine learning do progressively when they, but it needs some guidance, right? There's an example called flashlight, right? How machine learning and deep learning. Say, for example, I have audio trained, right? I have audio trained my application, right? As what I say, if I say dark, when I go to the room, and if I say dark, immediately what will happen? My lights will be switched on. All right. So that is in machine learning. Able to get it? So when I say lights, then it will be switched on. All right. If sorry, when I go to the room and I say if it is dark, then the lights will be switched on. All right. But if I'm not saying dark, right? But if I'm not saying, I'm not able to see why the room is like this. If I'm going to see, like, say these words, machine learning will not work. It can recognize only the word dark. But whereas in deep learning, if I go into the room and I say, I can't see, or if I see the light switch doesn't work, it's not the same word as dark, but it tries to synthesize and then the lights will be switched on. Able to find the difference? Machine learning and deep learning? Yes? Yes or no?
Yes, ma'am.
This is the difference between machine learning and deep learning. In deep learning, it has a layered structure of algorithms, all right? And then it will try to find it out, right? It will try to find it out and then it will work progressively. But in machine learning, whatever you have trained only should be working on with that, right? And it is trying to mimic the human brain. How many of you know this AlphaGo program? Oh, sorry, Go game. Go game, how many of you know? It is, how many of you know Go game? Yeah, Usha ma'am, you know Go game? I can see only one raise hands. All right. So Go game is something like a chess game, right? You know, now recently only Gukesh, right? He won the world's champion, right? When you see Go game, this looks like this. I'll show you, right? Can you see? It's very famous in China, right? How the what rules they have. This they also you have the white and the blacks, and you know this Google's Go Mind, right? Deep Mind, sorry, not Go Mind. Google's Deep Mind. They worked with this, right? They mastered the ancient Go game. Can you see here? And they inspired and they tried to make another AlphaGo, right? So they tried to work with the machines, the AI machine, and the world's topper Go game person also played, you know, AlphaGo won the game in comparison with the human, world's best player, right? Learned the mastery of Chinese Go game and it defeated the world champion, which defeated AlphaGo defeated it. Right? AlphaGo was developed using deep learning. So the amount of data is more, the performance is more. Amount of data is less, older learning algorithm. So when you see both differences, users parsing data, learn from the data, make informed decisions. All right. Then, yes, please. Any doubts?
லேபோட க்ளோஸ் பண்ணா students.
If you are not speaking, you can put your mics on mute. All right. Mic
Okay.
mute. No? I think the organizers can mute the mic. All right. That's good. Deep learning creates a new, as we have neurons in a brain, it tries to make the neurons, right? Subset of it. So I told you about, there are next concept that we are going to see. These are basic fundamentals, right? That's what we are seeing into it. Here, what is supervised learning? Like, you know the target values, right? This is an apple, right? I sent it to the supervisors. It has a training data. It knows what is the output, which means it has got a target. Then it has got its own algorithm. Then it develops it. I'm training using a red apple. I'm testing using a green apple, taking its structures and everything. It says this is also an apple. All right. Able to get it? Yes. So this is an example where you know the target, then you go on for supervised learning, right? When you know the target, then you go on for supervised learning. All right. When you don't know the target, can you see the difference here? You have the desired output. When you don't have the target, then it is unsupervised. So I'm trying to give different data sets like apples, orange, and mangoes. It tries to figure out its shapes, right? And then it tries to give it an algorithm. And with the shapes, it is clustering into apple, banana, and mangoes. All right. Yes. Able to get it? The difference between supervised learning and unsupervised learning. All right. And what happens in deep learning? In deep learning, in machine learning, we extract the features and then we build the classification model. But what happens in the deep learning? It both goes hand in hand, right? Both goes hand in hand. All right. Both machine learning and both feature extraction and classification, they go hand in hand. That's what people say. They are more they are more little better than the others, right? But yeah, but basically it also depends on how it works. But this is the heart of the concepts. This is the heart of the concepts. Any doubts till now? Any doubts till now?
No, ma'am. No, ma'am.
Only few are answering. I don't know what others.
Ma'am, we can proceed.
Right. Thank you.
Clear.
Now, how many of you worked with pandas? How many of you have worked with pandas? Yes or no? Yes? All right.
I have worked with pandas.
Yeah, thank you. Thank you, Manish sir. So what pandas, how many of you are new or you don't know about pandas? If you are new or you have not worked with pandas, you can click raise hands. Okay, Venkat, Surya, Muttamal, Nitya ma'am, Sandhya ma'am, many of you. All right, no problem. We'll see. All right. So what is pandas, right? It stands for pandas for data analysis, right? Let's move on to pandas. So here it has its own structure. right? Where it looks like table kind of data, and you can use it for merging, sorting, and whatever applications that you want to do. Slicing, I'll show you a demo of it. And I can also show you this website. You can also make a note of it. pandas.pydata.org. Can you make a note of it? Yes. All right. So here you see it gives you how to install pandas. All right. And when you come to documentation here, it gives you the entire user guide, how to use pandas. Can you see if you want to take data from a CSV file, how do you want to index it? All right. I'll show you. Yeah, I think this is about a heart disease data set, right? So I showed you the data set, right? You remember on UCI machine learning repository, even directly from that you can take a data, right? Directly from the data set you can use those data, right? And I've just taken it using pip install UCI ML repo, because everything comes in Python as package. You can also visit this website, which is called pypi.org. Can you make a note of it? All right. So here, whatever you want to develop in Python, I'm going to want to do it from UCI machine learning. Then I'm just searching. Then here itself, they give you here. See this, I showed you about this heart disease. Do you have an option called import in Python? Can you see it? Yes, when you click on that, you get this entire code. Then this is how you will be installing, right? Pip install UCI machine learning repository. From there, directly I'm going to import the data set, right? These are my features and target. Whenever it is target, it is called as clustering, right? The same thing I'm doing it here. I'm directly importing it. All right. So I'm just installing the package to import. And then I'm directly, this code is given by UCI itself. We can directly use it. So no problem in that. All right, there's no problem in that. So we'll be able to use it directly. I think it's running. Just give me a minute. Now I have taken the entire data set. All right. So I'm going to connect both the data set. So this is, I've taken all the features, right? All the features onto this variable called X, right? Variable called X, target onto Y, right? Target onto Y. So if I'm running here, it will X dot head. So in pandas, everything it comes into pandas here. So if you give X dot, if I want to import, we can import pandas as PD. All right. I don't know why it is quite slow. So I deleted. Okay. So I've imported pandas as PD. I'm trying to have the maximum columns because number of columns are more, right? I can, it's used by saying X dot shape, right? In pandas, if I import it, I can have it. So you can see how many rows are there. 253,000 rows are there. All right. So Because of that, I'm trying to use or 21 columns I would like to see. That's what in pandas I'm setting it as maximum columns. So what are the features for heart disease, high BP, high cholesterol, cholesterol check, BMI, right? Whether he's a smoker, he has got stroke or disease attack, heart disease or attack, or whether he is physically active, how many fruits he takes, vegetables, whether it's heavy alcohol consumption or any other healthcare, no Dr. BC cost or general health, right?
Ma'am, I
And
think no voice, ma'am.
no voice,
No,
are you
it's
not?
clear.
Voice is
there.
audible, ma'am.
Okay.
Yeah, it's
Audible.
Thank you. Thank
yeah,
you.
audible.
Sorry. All right. And then here you can have, I'm using this tool called Colab. I forgot to tell you that. How many of you used Colab? Are you aware of Colab? Yes or no? Kindly give me an answer, please. Anything is fine for me. I want an answer, yes or no. See if you are using, all right. I don't. All right. So, okay. So when Colab, it comes as a free tool. All right, Colab, it comes as a free tool with your Google. You can just type, if you're also using mobiles or systems, you can type colab.research.google.com. All right, that's the website. I can give you a bigger part of it. You can make a note of it. It will be very, very useful. I always, faculties, yeah, faculty should know more than students, right? Even though I'm busy, whenever it is FDP, I do accept it always, because I strongly believe when the faculties are trained through them, thousands and thousands of students could be trained. All right. This is a website. Kindly, you can make a note. Just log into your Gmail and then give this link. And all your data sets, that's the next level, but directly you can start working with it. The free package. Yes, colab.research.google.com. Okay. As time increases, no, number of people are also increasing. Right, nice. So this is the target. Mics on mute, please. The organizers can make anybody's knowingly they should have kept their mic on. You can mute it. All right. Now coming into this, using that only I'm trying to do this, right? So a target is whether they are a diabetic patients or not. Sorry, it's not heart patient. I've taken as diabetes patient data sets, CDC diabetic patient data set. And what I showed you is for heart disease, same thing, right? I mean, only the ID will change, right? So it's 303. That is for diabetes. It's for almost 253,000 or something or the other. All right. So this is my target, right? Whether they have got how many rows I have, same rows I have it in my target also. Can you see here? But here there is 21 rows. Here there is only one row, only one column. And the type of the data set, right? Whenever, whatever, if I import it into my pandas, the data type is of data frame. The data type is of data frame. All right. And then I'm concatenating both data sets because I want to merge both my features and my target, the features and my target. So now I made it as a DF, right? So I can find whether first patient is a diabetes patient or non-diabetes patient, right? 0 means they are non-diabetes. 1 is their diabetes. And in pandas, we have got two things. One is the pandas attribute, the other is pandas method. See here for head of, I used an open and close curly brace. For tail, head shows the first few rows. If I'm not going to give any values, it will be default, 5 rows will be shown, right? Tail, head. If I specify, because I have so many rows, if whatever number I'm going to specify, then I'll get approx. By default, it is 5, but I can specify whatever number I want. So this I'm trying to analyze it, right? And then whenever I don't have open and close parentheses, these are called pandas attributes, right? Methods will have open and close parentheses. Attributes will not have open and close parentheses. That's the difference. All right. All right. Now index will tell me how many rows and what steps they are in. All right. And then columns. What are the different columns we have? Axis will say how many axes, X and Y. Sometimes you can also work with multi-dimensional data. You can also work with multi-dimensional data. Right? What is data types? So here all the data types is of type integer. That's what it shows, integer 64. Right? What is the gender? What is the age? They are taken directly from hospital data set. So almost it is a benchmark data set. So what is shape? I told rows and columns. Can any of you guess what is size? How this value arrived? Can anyone of you say? It's multiplication of rows and columns. All right. How many dimensions? What is it? Listen carefully. I told you, right? Whenever I take any data set, it is of type data frame, but the values inside the data frame is of NumPy array. That's what you can see. DF and DF dot values will be NumPy. I showed you about NumPys, right? You remember during the session when the theory part was taken, that is called numerical Python. Listen to the session clearly, and last 5 minutes, we'll be having a multiple choice question quiz. Let's see who is the winner for the day. All right. And also I can take samples, and information will tell me if I'm going to have any missing values. Machine learning algorithm, you cannot work with even one missing values. So to check off with the missing values, I'm going to check df.info. This is a function, pandas function, right? Even sampling, if you want to sample out some data and then work, you can use sample of function. All right. Yes. You are able to understand till this? Are you all there with me? Yes or no?
Yes, ma'am.
Yes, ma'am.
Thank you. And this is a beautiful function in pandas, which is called NUnique, which will tell me what is the number of unique values. For high BP, it is 0, 1, low cholesterol, 0, 1, cholesterol check. But BMI, each of them have different, whether they're smoker, yes or no, stroke, yes or no, heart attack or heart disease, yes or no, right? Physical activity, fruits, vegetables, all yes or no, right? If it is for physical, mental health and all, the values are different, right? And gender and the age, right? And here, if you see, the unique age is 9, 7. Can you see it will be between 1 to 13, right? 1 to 13. I will show you this CDC diabetes data set. All right, it has come from this, right? US diabetes surveillance data set. So can you see this is the data set? Can you see the number is exactly the same? 253,021 rows. And you should try to understand what these means, right? What each of the columns mean, right? So for example, age, no? Can you see age is 13? It is not 1 to 13, it is 13 level category. See, if it is 1, it is 18 to 24. If it is 9, it is 60 to 64. If it is 13, 80 and older. There is something called 13 level age category code book. Right? If you don't understand, that's what, if you don't know the facts, then we will not be able to understand it, right? So this is mandatory for us to understand what is the 13 level age category. Just if you Google search it, you will get the codes here, right? And right, according to the code, it works, right? It's like, how do they take 1 to 13, right? 1 to 13, what is the age and what is the age category, 13 level category. Without knowing that, if you try to write your inferences like 1, 2, 3, 4, 5, 6, then it will not work, right? I can show you here. Can you see 1 is 18 to 24, age level 2 is 25 to 29, 3 is 30 to 34. Can you see this? So this is a description of those columns. Like patient, male is 1, female is 0. Like no cholesterol, 1, no cholesterol, check in 5 years, 1 cholesterol, 1 is, yes, they have checked cholesterol, BMI, have smoked 100 cigarettes in their lifetime. Right? 0 is no, 1 is yes, whether they have coronary heart disease or heart attack, physical activities for the past 30 days, whether they consume 1 fruit or more fruit per day, or these are the categories. Do they have difficulty in walking or climbing steps, whether they had stroke? 0 is they are not diabetics. 1 is they had physical injuries in the past 10 days. All right, mental poor health care, 1 to 30. General health is 5, you see, right? Like 1 is 5, excellent, and 2 is very good, 3 is good, 4 is poor, and 5 is, sorry, 4 is fair and 5 is poor. Heavy alcohol, like 14 drinks per week and greater than 7 drinks per week for men and women. Able to get it? So this is how you need to understand how the data set works. And then that is what, it's not like age 1 to 30. It follows the code, right? Before taking the data set, that's what I showed you the first picture. We should know the fact. Without knowing fact, if you start working, even you'll be good on machine learning algorithm, then you'll be plotting with 1 to 13 age, but your paper or publication or findings or whatever it is will be futile, right? So value counts will tell me how many people in this data set have diabetes or non-diabetes, right? So, and also BMI. I can put that into Seaborn. Some of you would have worked with Seaborn. This is a count plot. In this data set, I can find more people are non-diabetics, only less people are diabetes, right? And the visualization is better than this, right? With the count. So you can use it, just right click it, save it as image, and then you can use it for your publications, right? So I told you, right, you should not have any null values. So that is what df.isNull.SumOf is used to find whether there is no null values. All right. And also this is another package for visualization. All right. To figure out whether there's no missing values in this data set. All right. If there is going to be a missing value, then you'll have white lines. These are packages for missing number packages for finding out whether there is missing values or not. All right, even in pandas, we don't have much time. I think time is quite challenging for the session. And yeah, we can also group by age and BMI. I've done the group by age and BMI, and also by income, high cholesterol, and high BPs, right? So, and I'm grouping by physical health, all right? And multi-column also I can do education and diabetes and their sum of. So in education, what level and the diabetes levels, right? So this is another plot for, again, for count plots. And this is box plot to show the range, right? I said general one, see, when the health is good, the BMI is low. When the health is bad, the BMI ranges is more. Able to figure out? So like this, we need to write inferences, right? We need to write inferences, and also with diabetes and without diabetes. Here you can clearly say without diabetes, their BMI is less. With diabetes, their BMI is more. All right, this is what is so powerful of visualization. Once we do this is box and plot, right? It works with your kernel density estimate. This works with your kernel density estimates. All right. Any doubts till now? Or only I am speaking? Yes, no?
We were listening, ma'am.
All right. Any doubts till now? I don't know. Am I going fast? I'm going slow. I cannot see none of your cameras. I always keep my camera on for all my sessions, right? All right.
Ma'am, you are in the right direction, ma'am.
Okay, thank you. This is the next thing is the violin plot, right? How do you plot a violin, right? You see, you have a violin, you have the top, and where the kernel density is more, then the size, the width of the density is more, right? That is what kernel, according to the kernel density estimate. So it looks like a violin, right? And next is the point plot. It is not generating lot of charts. How do you write inference from that? It's very, very important. All right. And this is about bar plot, right? With diabetes and without diabetes. The general health. Onto the x-axis, I've taken general health, and y-axis BMI. So here clearly says when the body mass index is higher, there could be a clear diabetes. All right. And this is called the heat maps, right? Heat maps, it works with correlation, right? You know, different correlations you can do it in pandas. One is Pearson's, Spearman, all right? And by default, it is Pearson. And Kendall's correlation also you can do. But by default, if I'm not going to give anything and just I'm going to give df.corr and then it gives me Pearson's correlation. And the correlation between this column and the target. So what is my target here? Diabetes, binary. See, whenever it is lower, if it is negative, then these are not good features for me to build my machine learning algorithm. All right. So I think I'll stop with this here. And any questions I can take. And so in machine learning, you need to first define what problem. Here we have taken heart disease. We need to prepare data, find out any missing values or any outliers are present. And then we need to evaluate algorithms, right? And improve the results, and we need to present results. All right, what I'm going to do, will play a game. All right. I don't know. Ma'am, you have any WhatsApp group for this team? Or if I could give the link, whether they'd be able to get the link. I've given a link to questions. I don't know. Chat is not working for me. If I click refresh, sometimes it goes off. So I've given the link on the question and answers. Can you click the link and join the quiz, please? So just the link to Shanbak, ma'am. If you have got a WhatsApp group for this FTP, ma'am.
We will share everything, ma'am. Your PPT and your work and all shared in that group, ma'am.
No. The link what I've given to you now, can you share it onto the group?
Yeah, sure, ma'am. Sure, ma'am.
I'll see how many of them are joining.
Yeah, yes, ma'am. Yes,
or you can also scan this QR code or give slido.com and then give this number and join the quiz.
Yes, ma'am. I have shared them.
I can.
Then, yes, ma'am. The link has been shared in the Atal group. Yes, ma'am.
Data validation, madam.
Validating the data.
Data validation, madam.
we need, for data validation, we need to figure out whether, because we mostly take, I personally recommend people to take it from benchmark data sets. Only thing in validation, you need to check for any outliers are there. Let's start with the quiz. First, let's see who has answered. 24 have joined out of 155. Yes, deep learning is machine learning because it's on the first place we have Chadravedlu professor, second is Munir, and professor, third is Jagdish. Let's move on to the second question. Oops. Untitled. Machine learning model, computer vision, deep learning. AlphaGo. AlphaGo is an example of what? The answer is AlphaGo is an example of which model? AlphaGo is an example of which model? I don't know where the second question. All right. The right answer is deep learning. AlphaGo is of deep learning. I'm sorry, the question had not presented properly. Dr. Usha ma'am is on the first place, Jagdish sir on the second place, and Kalpana ma'am on the third place. Let's move on to the third question for the day. Which model identifies to which category an object belongs to? Okay, the right answer is classification was again Dr. Usha ma'am, second Dr. Anish sir, and third is Jagdish sir. Let's move on to the fourth question for the day. All right. And the right answer is super-based learning on the first place. Again, Usha ma'am, Anish sir, and Jagdish sir. Final question that will define who is the winner of the day. Which package is used to interpret images and videos? Out of 150, we have 40 participants. All right, and the right answer is computer vision. And the winner of the day is Dr. Usha Banu ma'am. Congratulations. Next is Dr. Anish sir, and third is Dr. J. Vanita ma'am. And fourth, it is Kalpana ma'am and Premlata ma'am. Congratulations to all the winners. All right.
Thank you, ma'am. Thank you. Thank you.
So, the learnings of today, I wish first you can just click on the link and you can give what are the 3 learnings in today's session. All right. So you can click on the link and then you can make a note of my contacts, right? Exactly. I want to complete by 7:30. 8 o'clock, I have another meeting to join back. All right. I hope the session would have been useful. Click on the link and give 3 of your learnings. All right. And you can visit the YouTube channel, Doreen Robin, and my LinkedIn page is also Doreen Robin, on Instagram and on. Yeah. Thank you so much. And this is a company's website, CIP.co.in. For faculties, we provide faculty internships and also student internship. All right, anybody is interested to learn our implant training, you can approach us, and the different services that we provide, it is beneficial, then you could contact us. All right. Thank you so much to the organizers.
Thank you, ma'am. Thank you for your valuable session. Yes, ma'am. Participants, if you have any questions, if you want to share any feedback, you can share now.
Ma'am, any data set repository for India, ma'am, apart from UCI?
Data set?
Data set repository, UCI repository, like that Indian set.
Yeah, a lot of repositories are there, but we need to search it out and find the authenticity of it. Many governments, many country government also they give. We can use it. To begin kickstarting, I generally say UCI is better. Yes, please. Any other questions?
Thank you, participants. Thank you, ma'am. Thank you for your valuable session. Yes, today our resource person, Dr. Doreen Robin, ma'am, a data scientist and keynote speaker, ML deep learning trainer, director at CIRF, delivered an excellent session on introduction to machine learning, foundations and applications. She provided a comprehensive overview of machine learning basics, including the supervised learning, unsupervised learning, the need of target label and all, and clearly highlighted the difference between machine learning and deep learning. Additionally, ma'am gave a clear explanation of data visualization techniques using the diabetics dataset was very nice. The hands-on session with the dataset was particularly engaging and well executed. Thank you for your valuable session to the participants, ma'am. Thank you so much.
Thank you, ma'am. Bye.
Thank you so much, ma'am.
Yes, ma'am. Ma'am, kindly provide your PPT also. We will. We need to share the PPT to the participants through the WhatsApp group, ma'am. Yes, ma'am. Thank you, ma'am. Thank you so much.
Thank you, ma'am.
Thank you, ma'am. Thank you so much. The
session was awesome, actually. Thank you so much.
Thank you. Thank you. Participants.
Wonderful session.
Another one. Yes, sir. Thank you for another one for our resource person. Participants, I welcome you all for the day 3, session 6. Session 6, the topic AI-driven decision making, leveraging data science in financial services. Session going to handle by Dr. Mr. Abdul Sadiq, senior data scientist at Fidelity Investment. Abdul Sadiq, hope you arrived. Will you please come in video mode, please?
Yeah, can you hear me and see me?
Yeah, yes, you are audible. Thank you, Abdul Sadiq. We welcome you for the today's session. And I invite Ms. G. Sandhya ma'am, Assistant Professor, Senior Grade, Department of Information Technology, to brief about today resource person to the participants.
Yes.
Sandhya ma'am.
Yes, ma'am. Good evening, everyone. It is my pleasure to introduce today's expert speaker, Mr. K.M. Abdul Sadiq, a data science consultant with extensive experience in the technological industry. With a strong background in machine learning, statistical modeling, data science, and data visualization, he brings a wealth of knowledge in transforming complex data into actionable insights. Mr. Abdul Sadiq currently serves as a senior data scientist at Fidelity Investment, where he has been making significant contributions since December 2018. Prior to this, he worked as a data science consultant at Altimetric, where he worked on projects for prominent clients like PayPal, focusing on anomaly detection and business performance analysis. Mr. Abdul Sadiq is also certified in multiple areas, including IBM's Pure Data for Analytics, Business Analytics, Data Reduction Techniques, Logistic Regression in R and Excel, Artificial Intelligence Practitioner, and Data Science Foundation. We are fortunate to have Mr. Abdul Sadiq with us today to share insights from vast experience in data science and analytics. I welcome Mr. Abdul Sadiq to lead us through this insightful session. Welcome you, sir.
Hey, thank you. First of all, thanks for this warm welcoming. Nice to hear about this, and thanks everyone for inviting me. And of course, big appreciation for students and faculty members for listening in for this session at this time of the day. Without much ado, probably let's get started on our topic. Okay, as I am sharing my content, probably a couple of things as a disclaimer, I just wanted to mention. Yes, this is going to be on AI, related to how financial services are utilizing AI on their various operations and business fields. But the main disclaimer here is that please don't take anything as a financial or investment advice, right? These are from what's happening in the industry. This may not work for your financial investment strategies. So don't take it as an financial advice. Take it from an technical aspect. See how you can use this for various business operations, right? And other disclaimer, probably ma'am has mentioned, like I am coming from an corporate background. I am not a trained speaker, so please bear with me with my presentation skills. And of course, feel free to ask questions, then and there. If you have anything, please don't feel shy to stop me and asking questions, right? Probably we'll get started with this today's topic, AI-driven decision making. Of course, we will see how financial services are leveraging AI and machine learning models in their everyday tasks. Myself, Abdul Sadiq, working as an senior data scientist in an investing firm in Chennai. So, what is financial services, right? I mean, I know there are a lot of students here. Does anyone want to guess what is financial services? What do they do predominantly? Anybody want to guess? So, can you give me an example of a financial services? Okay, maybe it could be a tough question. Probably I will get started. See, financial services, they, it's like any other services, right? So they provide certain financial, goods and services to us. Something like banks, right? So what does a bank do? They create us, help us help us creating a savings account, business accounts, transfer the monies. Then there is
Abdul Sadiq. Abdul Sadiq,
Yes.
actually getting some background voice.
Yeah, I can assure it's not coming from my end.
Okay.
Muted, sir. Muted. You continue.
Yeah, please. So then there is banks, and then there is investment houses. What does an investment house does, right? It provides us stocks, various bonds, corporate bonds, right? So basically they help us to, park our money in certain investments, something like, ICICI Direct, Zerodha, these are the investment houses, right? And then there are insurance companies which helps us to secure our future, right? Like Axis and, ICICI Prudential. So these are the insurance companies help us, to secure our futures and our wealth, right? So there are so many financial services. Now the question is, why do they need AI, right? And how did they do without AI, right? AI is relatively newer technology, right, in terms of adoption. But does it mean that these companies doesn't perform well, without AI, right, in the past, right? That was not the case. So AI is more of like, it's to enhance the financial process, right? How do they do? There are a lot of things which we will see. Something like how do they enhance the customer experience, identify frauds, right, and then probably scale their business, right, which will having, which were not very straightforward, were not easy in the past, but with the help of AI, these financial services were able to strive to their perfection. And we will see how do they do with some practical examples, right? But before that, probably, let's step back and then see what are the benefits of AI, right? As I mentioned, the key benefits would be faster decision making, right? So what is the difference between AI and a rule-based system, right? So a rule-based system is where you have certain rules, right? If so and so things happen, then this is the action that the system has to take, right? For instance, there could be forms, right? Then you have to fill up the forms. If you fill up the forms, then once you do click a submit option, then it should submit that form, the data to the whatever organization the form has created, right? So that is a rule. Let's say within that form there is a checkbox that asks for phone number, right? So in that phone number, can you give any alphabets? We can't, right? Why we can't give alphabets? Because in the background there has been set certain rules where we can't give alphabets, and it would be expecting only numerical values, right? So again, that is a rule that explicitly you are setting up. So with rule we were able to manage so far, but there are certain things that only humans can do, right? Probably setting a price of a property, right? Probably, some of you folks have heard about house price prediction, right? Can you tell why it would be difficult for creating rules to predict a house price? Does anyone wants to take a shot? Why do we need a AI to predict a house price? Or let's say this is a season of rains. Let's say you have a lot of data. You have data of perception, you have data of the wind, cyclone movement, the temperature. So there are a lot of data available. And now you have been asked to predict whether it would rain tomorrow or not, right? So there are two ways to go about it, right? Or I would say three ways. The first way is as a machine, you can write explicit codes, right? If the temperature is so and so, and if the wind velocity is so and so, it's moving in this direction, then say it will rain, right? Just if conditions, if and for loops, if conditions, you can just make it, and then you can create a rule, right? If and else. The other way is you can, as a human, you can look into the data, right? Bring your experience, right? Probably you would have seen last year with the same temperature, with the same wind velocity and the direction, you would have seen that, okay, there was rain last time, and based on your experience, based on your gut feeling, you might be telling that, okay, because it rained last time with the same environment, it's more likely to rain this time as well, because we are having a similar pattern, right? So that is human. Now the third way is where the session is all about, is using AI, right? Now AI, what it will do is it will try to replicate what the human tried to do here, right? Like as a human, we try to look into the data, past data, the present data, and we try to predict the future, right? Now, can you tell me what is the advantage or disadvantage between these three processes? What do you think? What would be the advantage of AI over humans, or AI over a rule-based system?
AI can process huge amount of data and give a quick decision on that. That's the big advantage, I think, sir.
Right. I guess Senthil Kumar answered that. Yeah, that is one of the key advantage, right? Like as a human, we are limited resource, right? Like you can't So I just said probably 4 or 5 features, and there could be a lot of features that would impact a particular event, right? As a human, and we just looked into last year data. What about last 5 years, last 10 years, last decade worth of data, right? As a human, it would it's not impossible, but it becomes very challenging. And again, there would be some amount of bias, right, from a human mindset. You might be thinking, okay, Chennai December always rains, so that is the bias, that is coming in to the picture, right? As a human, that you will be bringing that. So these are the disadvantages with human doing that prediction. And then I think one of the other key important point in that is the scale, right? Probably for one day, maybe you can look into the data and then say, right? What about for Chennai, it's fine. What about all the districts of Tamil Nadu, right? What about all the districts of India, right? And across the globe, right? Just for one day, right? Just for tomorrow, you have to predict whether it will rain or not for all the districts across India, right? I don't know how many districts will be, probably it would be more than thousands, right? So just think about the number of data you have to review and then make a decision just for one day, right? So as a human, it would be very difficult, right? And that's where AI is coming into picture. But the other part is, what do you think would be challenging in terms of not having a rule-based system, right? Why don't we go with a rule-based system? Why do we need an AI? Why do we need such a complex system? So rules is like just an if-else condition, right? If temperature is, let's say, 20 degrees Celsius, right? And wind is moving at, maybe 30 kilometers per hour, right? So, and then it is a December month, and this is the first week of December, right? So, and humidity level is 76%. So these are the data that you have, assume. And then on top of that, you are creating rules, right? So if this condition fails, if this condition passes, then say it will rain, right? It's simple, right? But what do you think there would be what do you think would be a disadvantage with going with that rule-based system? Do you think it would be better than AI? A rule would be better than AI? See, basically, it's very easy, right? It's easy to write. If-else condition, almost all programming languages comes with a static syntax of if-else condition, right? So probably most of you know how to write a rule, right? But the problem is, it's very dynamic, right? You cannot say, okay, if the weather is if the weather and the air or the wind condition will always give rains, right? So there are a lot of factors. Just imagine let's say if you have 100 of features, just imagine creating hundreds of if-else conditions, right? And then suddenly there's a lot of effects like El Nino effect and a lot of other things happening. It's not very static. Things keep changing, things keep evolving, right? And then again you have to change all those 100 rules, right? And then it becomes very complex, right, to maintain and to update, right? So that's where rule-based system becomes very challenging to maintain, and that's where AI is it's a blend of taking the benefits of rule-based and then the human intervention, and then trying to replicate what it can be done, right? So that's where AI comes in. And now just taking the same concept and applying it on financial industries, right? So we will probably look into how these things are offered, right? As I mentioned, you can take faster decision because it's not you taking the decision, but AI is looking into the data and then helping you taking the decision, right? And then of course there's be low operation cost, right? Like cost of an resource person, right? Like an employee would be very less compared to cost of an AI, right? Setting up an AI, right? So those are the main benefits, and we will probably as I mentioned, see with an example, right? Without further ado, right? Some of the key applications, and probably I wanted to go through samples of this. First and foremost, this is probably a hot topic in financial industry, that is fraud, right? So most of you heard about lot of frauds like spam calls, phishing, hacking, right? So a lot of things are happening, right? Now there are systems in place, there are rules in place, humans in place, but still these frauds are not stopping, right? So how can we leverage AI to identify and then prevent frauds before even it has been customers are getting impacted, right? So how to do that? And next is in terms of decision making. As I mentioned, there are a lot of things, when you come into a financial domain, there are a lot of decisions has to be made, right? We will look into one example, but something like, let's say, about mutual funds, right? And I guess about what an active mutual fund is, right? So active mutual fund is where a fund manager will actively look into the stocks and then manage the portfolio, right? Based on what's happening, based on the market conditions, based on the company's performance, that stock market, the manager, that is the portfolio manager, might optimize that portfolio, right? So then there's a lot of decisions has to be taken, right? And that is the case of an active funds, but there are a lot of other cases where you have to take decisions on split seconds, right? Whether to invest in this company, whether to de-invest, whether to buy the shares, buy the gold, which one should be the better option. Again, it need not necessarily to be a single person, but think of an mutual fund, think of an large corporates, right? So they have to make decisions, and these decisions will always has to be come from data, right? You cannot just like that have a gut feeling and then take a decision, right? Okay, I think I cannot say, okay, I like this company's ad and I think this will grow further because they have put some prominent actors in the ad, right? We cannot say, okay, because he's a superstar, this company will perform big in next 10 years. You cannot say that, right? So you need data driven decision. So what are the data? As I mentioned, the market conditions, how does the company perform, how does the business of that company, let's say if you are going into cell phones, right? This company is producing cell phones. How does the cell phone market would be in the future, in the next 10 years, right? And how does this company, what is the share of these companies in that market segment, right? So, and what is the peer, what is the competitive analysis being done on these companies? So there's lot of benchmarking, lot of data analysis has to be done, and that's where decision making has to be depends on data driven insights, and where the AI will come into picture. And repetition of tasks, as I mentioned, there are a lot of tasks you can automate, and of course it's been there, right? It's not a new concept, automation, right? So there's RPA, robotic process automations, where you can directly code the rule, tell if you let's say if you have a parcel, then pick it up, right? So there's a lot of automation you can do, but as I mentioned, if the tasks get sophisticated, right, then writing rules becomes very complicated, right? So that's where AI would come into picture. And customer experience, enhancing the customer experience, right? Like the easiest way to enhance the customer experience is to put a representative, right? An agent on the other side, right? But imagine for every customer, if they keep having a representative, then just imagine how big the cost to that company, right? You can't keep giving the salary for every representative, right? So that's where you wanted to have a AI behind the screen where they can handle like a human being, how a human being would handle, right? So we will look into some of this use case as well. Probably we'll jump into, we'll start with the first use case, the fraud detection. But before we go, do you have any questions, or do you have any feedback on the pace of how I move? Do you want me to slow down, or do you have any specific questions on this topic? Any questions? No questions? Okay. Hope my pace, you are keeping up with my pace. Let me know if you want me to slow down, or let me know if you want to have more clarity on any specific topics that we are discussed, or even let me know if you want to talk about anything else. Yeah.
Yeah, you can proceed, sir. You are in normal flow.
Okay. Okay. Sure. Thanks. Thanks for this acknowledgement. Okay. Let's look into this fraud detection and fraud loss, right? Like before that, we just want to understand what is a fraud, right? Okay, probably, I guess this is a simple question, but can you give me some examples of frauds in financial institution? Probably something you might have heard in news, you might have encountered yourself, or someone, would have
The
encountered.
hacking our Facebook ID and asking money from our friends.
Yes, yes. Hacking Facebook ID, yes. Asking money from friends. So that is some kind of an hacking on your social media accounts. Yeah, that's a good point, man. Anything else? Anything specific to financial industries? As a customer,
Like giving calls that we will buy on your name, something like that.
Right, right. So that is what they call as phishing, right? Phone hacking or social engineering, right? So they will call you and then they will tell, you have won a lottery. It's an urgent mail. There is a parcel waiting for you. All you have to do is just share an OTP, right? The moment you send an OTP to them, share an OTP to them, then the money in your account gets wiped out, right? Yes, that's a good point. And again, if you notice here, they don't technically hack you, right? They just get information from yourself, right? So this could happen. A lot of the population will be targeted towards elderly people, people that are less educated, right? So these are the people they would target. Yeah, these are the good use cases. Probably in the benefit of time, I will get going. So apart from this, there are other frauds, right? Something like your credit card or debit card gets stolen, right? Someone hacks into it, and someone looks into your, cracks your password, right? Like greedy search, he just writes a lot of passwords. Let's say if you have very simple password like password 123 India 99, right? Something like this. And then they can easily crack your account and then steal your money, right? Now the onus is on the customer as well as the financial institution for them to secure your account, right? How do they secure? We will probably see in one example, but let's just look into the data, right? In a recent report, it was mentioned that in the last 9 months, right, from from Jan to September, just in this year, Indian customers have lost around 11 crore, right? 11.3 crores in cyber frauds, right? And this is an increase from 20, it's 20% hike. Can you imagine? The inflation itself is just 5 to 6%, but the hike of fraud rate is 20%. So that the story that you can see here is that the fraudsters are becoming very advanced, right? Their modus operandi is becoming very sophisticated, right? Days are gone where they just call you and then say, you have won a lottery, right? Nowadays, you don't get a call that you have won a lottery, right? No one does that because everyone is aware. Now they are moving ahead, right? So they are making different kind of fraud. So you could have heard about this, posting as an CBI officers or police officers, like you have money laundering, you have a drugs. So, they would start to escort money, right? So they are doing a lot of sophisticated hacks. They tap into your calls, they tap into your SIM cards, and then, get your passwords. So they are getting updated. So as the system has to be get updated, right? To secure, to shield the accounts. And of course, that's where AI would come into picture on helping customers to safeguard their financial interest. right? And as you can see, right, this is not just for India. It's overall there is a huge increase in the frauds, right? Worldwide, and as you can see, specific to Asia Pacific and then America, there is a the hackers, the fraudsters are targeting those regions. Maybe they might found that we are the wealthy and we are easily forgiving, so they are targeting these customers and then increasing their play, right? Now probably let's get into action, right? Enough of discussions. Probably I might have repeated certain things that you already know. Apologies for me. But now let's get into some action. How do we use AI, right? So we have been talking a lot about AI, right? So what fraud detection means, you have seen lot of fraud use cases, lot of fraud cases in the past, right? And now as a what we try to do is we try to build a model that would replicate those fraud scenarios, right? We will train a model that would replicate those fraud cases, and then let's say in the next instance, if let's say in the future, if some customer goes through into a similar scenario, right, and the model would have seen a similar scenario in the past that would have resulted in a fraud, now the model would alert the system, say, hey, this looks very similar to a past fraudulent activity, so this could be a fraudulent case, right? So probably we have to take necessary action, right? So what is the action that depends upon the appetite of the bank or the gravity of that situation, right? Probably they could stop the transaction or they could escalate the transaction for further due diligence and then take necessary actions. That depends on how the business setup. But alerting that process is where machine would come into picture, right? Now again, when we say alerting, see now just go back to the previous conversation, right? So there are three ways of doing it, right? As I mentioned, you can have a rule-based system, you can have a human, or you can have a machine learning model, right? So rule-based system, as I mentioned, it becomes very complicated, right? The rules itself is very large, right? So you cannot keep updating or you cannot keep writing lengthy rules, right? As I mentioned, the hackers, the fraudsters were evolving, they are getting upgraded. So updating the rules become very challenging, right? So that option is gone. With the human, so there are millions and trillions of transactions happening every day, right? It's nearly impossible for the humans to deploy, the banks to deploy humans and then review each and every transactions, right? And that's where the combination of humans and the rules, the AI would come into picture, right? It will look into large volume of data and it will replicate what a human would ideally do, right? Based on the experience it would have learned from the past, right? So how does a human would know whether, how can a human would predict whether a particular transaction would be fraud or not, right? It would be based on his past experience, right? Whatever data he would have seen, and that is what we would make the model to learn, train, and then make that prediction, right? We will get into an use case. Let me try sharing my notebook. Okay, let me know once you see. Okay, while I'm sharing, I'm assuming you guys are familiar with Python, right? At least basics of Python. Because this would be slightly on the Python, right? I mean, if you're not very familiar, probably I will not go through the code much. Anyway, we have limited time, but I will just share you the business, the actual background, and what is the insights that we are deriving, right? Okay, so as I mentioned, we would be having humongous of data to analyze, right? So let's say this is one sample data set, right? Where that this has fraud this basically has transactions, right? So there is a lot of transactions. What we have is the transaction ID, the value of the transaction, and the time, right? Time. So time is in seconds here. That is from 12 hours. And then we also have through which merchant the transaction occurred, right? And what is the type of that card, whether it's a debit card, credit card, age of the customer, gender of the customer, whether it is a foreign transaction or local transaction. If it is a foreign transaction, and there's an indicator saying whether it is coming from a high risk country, right? So high risk country, there are countries where certain institutions would mark as high risk. Let's say any country outside of your homeland could be an high risk country, right? Especially if that country is known for such fraudulent activities, right? One such country could be, let's say, Sudan, Namibia, right? So there are, and even Russia, right? So there were fraudulent activities that were, mass fraudulent activities that were reported in those countries, and probably we might not have traveled in those countries, so that might be an high risk country for us, right? And then the last column is the class that is going to be our predicted variable, right? So this will say whether this is a fraud or not, right? So we already have a labeled data set, right? With this feature, the class 0 represents it is not a fraud, it is an benign transaction, whereas 1 represents it is a fraudulent transaction, right? So we might have like 10 columns, and the first 9 columns called as features, right? Or we can say independent variables, and the last column class represents our target variable, right? Or otherwise dependent variable, right? Why we say dependent variable? Why do we say class as a dependent variable? Any guess? So class is the variable we want to predict, right? That will tell whether it is a fraud, whether that transaction is fraud or not, right? Each record represents a transaction, and this class represents whether that particular transaction, let's say class. So here what you are seeing is that class 1 to 5, transaction 1 to 5 are all of class 0, mean none of these transactions are fraudulent, right? Now the question is, we call this class or whatever column that we want to predict as an dependent variable, and the other columns as independent variable. Do you know why we call this target variable as an dependent variable? Why do you think it's dependent? Any guess? I saw like in the previous session, I think they took some basics of AI and ML. Students, anybody want to guess why it's a dependent variable? Okay, probably it's because you have a lot of staffs.
Independent, sir. The merchant is independent, card type is independent, all are independent. Only the class value is going to be depend where the fraud has happened and all will be known at the class. That is why it is dependent.
Yes, Chaturvedi, good guess. Yes. So what we are seeing here is that see, this fraud, whether it occurred or not, what we are trying to say is it depends on all these values, right? It depends on the values of these features, right? So now what the model is going to do is, so now probably this example might be a little complicated. That's why I'm going back to that rain example, which would be very easy, right? Let's say if the climate is too cold, right? And the wind is also, it's a breezy, right? It's very dark. There's a lot of, dark clouds you are seeing, and it's a month of December, right? Now the month value is December here, right? The climate, the temperature value, now temperature is another column, right? Imagine that value is, let's say, 20 degrees Celsius, right? Now, whether it will rain or not for this climate, right? That is going to be a dependent, because the rain is going to be dependent on the temperature and the the weather, the cloud movement, right? The cloud movement is not dependent on the rain, right? The temperature is not dependent on the rain, right? In this case, you are trying to predict whether it's going to rain or not. How are you going to predict? What are the data points you are going to depend for your prediction? You can't see, you can't say just by that you can say it will rain or not, right? That's not how it's going to be. It has to be data driven, right? When we say data driven, you are depending on certain data, right? So those data are called as dependent data, right? So in this case, class here is a independent, or class is a dependent, and all these features are independent, right? Because this gender and the amount are not dependent on each other, right? It could be any gender can transact on any value, right? And any merchant, right? Any gender can transact on any merchants, right? You can, I can transact on Flipkart, my wife can transact on Flipkart or Amazon, right? So gender merchants are not dependent on each other. But whether it is a fraud or not, it's going to be depend on these features, right? So let's say an aged person is going to, in his account, in his, let's say in his debit card, let's say he's 60 or 70 plus, right? And he is into Amazon, right? And he has transacted for purchase something, or does a transaction for let's say 1 lakh rupees, right? And then that too in early morning 3 a.m., right? What do you think this transaction would be? First of all, are you suspicious about this transaction? A transaction occurring at early morning 9 p.m., 9 a.m. or 3 a.m. For a value of 1 lakh rupees in Amazon. The customer is, let's say, female of age 70 plus. And again, the transaction is happening from an foreign country, but it's an Indian card. Do you think it is suspicious? It's worth suspicious? It's suspicious, right? Because you will not expect such kind of transactions, right? And now your decision of being suspicious or not, it's depending on these features, right? So that is what the model is going to do. We will train the model to say what are the things that are suspicious, what are the things that are not suspicious. Now again, you can create rule to do that, but we are not going to do that way because we are seeing the disadvantages of that. So we would make the model to learn from the past such fraud incidents, and then we will train the model from that past incidents and make it learn from basically learning from the mistakes, right? So we will make the model to learn from the past fraud cases, and in future if something happens again, then the model would flag, right? That's the whole idea. But before doing modeling, the common task we always tend to do is EDA, or exploratory data analysis, right? We wanted to analyze the data. We want to explore the data, right? So let's take this example, right? Class is what calls us whether it is fraud or not, right? Now, as I mentioned, this data, sample data, contains 10,000s of transactions, right? And there are 10 features, basically 9 features and 1 target column, right? With those 10,000s of transactions. Now look into that class column, right? Whether a given transaction is fraud or not. So as I mentioned, for 10,000 transactions, what we have here is a count plot, right? You're seeing the distribution of whether it is fraud or not, right? Anybody want to guess what this, what do you infer from this plot? The x-axis represents fraud and non-fraud. The y-axis represents the count of transactions. Right? The blue ones, of course, it's non-fraud, and the orange ones are fraud. What would be your interpretation from this plot? Any guess?
Most of the transactions are not fraud. It's a genuine one.
Right, ma'am. Yes. See, and that is going to be the real world scenario as well, right? Like, it's not all the transactions are going to be fraud, or not major, or most of the transactions are not going to be fraud, right? Frauds happens very rarely, right? We have probably, let's say, we have hundreds of participants here, 150 people, right? Chances of encountering a fraud among our population itself would be very few, right? Or maybe 1 or 2, probably maximum 5 people would have encountered fraud, right? Out of this 150. So this is how this is a replication of a fraud in the real world, right? Now the challenge here is to train the model with that less occurrence of data, right? We want to train the model where it will get the learning from the rarest of this event, and then predict those cases, right? So yeah, we will probably, you might get into that. We don't want to get into detail of that, but yeah, this is what we also call as in machine learning terms, class imbalanced data set, right? So this is not a balance, right? So balance is more of like 50-50, right? You have, let's say, if you have 2 classes or 2 predictions you have to make, and both of them were close to 50%, then that is more of balanced, right? If it's not balanced, then we call, there are many terms like imbalance, severely imbalanced. Then this comes under the category of extremely imbalanced, right? Because the fraud itself is very rare event, right? And that's what we are seeing here. Out of 10,000s of transactions, we probably have 100 of transactions marked as fraud, right? And that's what we could see from this count plot. We want to explore what are the other things that we have in the data, right? We also see the fraud rate across different merchants, right? We wanted to, so there are 2 things that we can observe, right? Amazon probably has a lot of transactions compared to all other categories. So if you can see both Amazon, Flipkart combined, we could see there's a lot of transaction happening. So that tells that e-commerce is where a lot of transaction happening compared to all other sites. But the green ones you see here represents the fraud cases. Right. So why do we want to do this plot? We wanted to see, okay, we have seen, we got an idea that, okay, frauds are very rarely occurring, event. But now we wanted to see, is there any pattern in certain merchants, right? Again, this is a sample data set, or you can say it's a toy data set. Nothing of this is coming from real world happening, but we just wanted to make it more realistic. So that's why the certain company names mentioned here. So as you can see, probably the second company, Agoda, might have less fraud cases compared to the e-commerce websites like Amazon and Flipkart, right? That could also be because there are a lot of transaction happening in those merchants compared to these cases, right? So that number of transactions, so wherever the transactions are higher, the fraud cases will tend to go higher as well, right? So that's where you can catch fish when there's lot of fish in the sea, right? Now, the other thing we can do is analyze the transaction amount, right? For fraud versus non-fraud. So this is what we called as an kernel density estimator, or an other version of an histogram, right? So this will give us the density of the fraud, the transaction amount, right? This is little complex, but probably I will stop here and then see if anybody can guess or interpret what does this plot shows. So the bottom lines, the x-axis represents the transaction value, right? Y-axis represents the density, or otherwise you can tell the frequency of the transaction, right? And the color codes represents, whether it is a fraud or non-fraud transaction. So green is a non-fraud transactions. So as I mentioned, right, like we have 10,000s of transactions, right? So green represents those non-fraud cases and red represents the fraud cases, transactions of those fraud cases. Now, anybody want to take a dig and then, tell what do you interpret from this plot? It's a little complex. Yeah.
Actually, it's like if we take student mark na, then it should fall in the form of well-shaped curve, like it is a normal distribution, right? So, but it was somewhat different than that of normal distribution. That means we know very well fraudulent activity and non-fraudulent fraudulent activity. It's not like a normal case, right? It's some exceptional or something not in the normal scenario. If we take a classroom mark analysis, it's a normal thing only. So definitely some weak mark students, higher mark students will be there, and also failures will be there. Other than that, all other marks are in the average. So the class mark analysis should fall in the well-shaped curve, normal distribution. Okay. So it is different than that of this. That could I identify from this one.
Yes, ma'am. Yeah, that is a great observation. And yeah, thanks for bringing that bell curve. Yes, so yeah, you would have heard about this bell curve where, it would be shaped like a bell, and, the common or most people would be coming between that center of that bell curve, whereas there will be outliers, as ma'am said, there will be distinct people having distinction marks, and there will be people who might not be performing well for that subject, right? So that is what's about the distribution of the students' mark, right? So that is a good parallel example. Now, as you can see, right, the non-fraud case, it's skewed towards right, meaning it's common, right? Like lot of people would be spending on lower value transactions, right? Compared, and there are very few people they would spend higher value amounts, right? Not about people, but let's assume, right? Let's take you yourself as an example, right? Let's say probably in the last 1 year, you might have done thousands of transactions, right? And if you plot a curve, right, plot a distribution curve, and you could see that most of the transactions that you have done would be smaller values, right? And in very rare occasions, you would have done transactions of high value, right? Something like you would have purchased a vehicle or property, something. So that high value transaction would be very rare, right? But the common transaction that you might be doing, like probably you would have GPay, you would have paid to an auto, you would have paid to a shop. These transactions would be of smaller amounts, and that is what would make up that whole pie, right? And that is what a normal non-fraud transaction would also says, right? So the x-axis here represents transaction value, right? Again, these are in dollars, right? So from 0 to 50 is $250 is where most of the non-fraud customers tend to do. But whereas if you look into fraudulent transactions, right? Again, there is a lot of transactions happening within that 0 to 50, but you can see outside of 50 also there is a lot of the number of fraud transactions itself is very less compared to non-fraud, right? But interestingly, the value of transaction is very high, right? So the number of transactions that is greater than 250 is very high in non-fraud compared to, very high in fraud compared to non-fraud, right? That's where you can see this area, right? boundary, outside the boundary of this green and within the boundary of red, right? That is transactions greater than 250 and till it goes 750, right? So there is almost no presence of green area. That represents there is not many customers do non-fraud customers do such transactions in that transaction amount, but there is lot of non-fraud, there's lot of fraud activity that is happening in that area, right? So think about it, right? Like if you are the fraudster, you have access to an customer's account, then you definitely try to make use of that account, right? Like use of that opportunity and then swipe the amount as much as possible, right? So mostly the customers, the fraudsters tend to do huge transactions, huge value transactions once they hack into that account, right? And then last but not the least, so this is something that I wanted to share, right? Again, that so there are multiple ways of looking into the data, multiple plots. So this is an distribution plot, and you might have heard about box plots. Yeah, again, interest of time, quickly, box plot is where we would summarize the distribution of the data. Again, that would give us the mean, the quartiles, Q1, Q2 quartiles, and also the extreme values, right? So this is the center line represents the mean value, the boundaries represents the Q1 and Q3, meaning quartile 1 and quartile 25% of the data and the 75 percentile of the data, right? And I'm sorry, this is the boundary of this box represents the 25 and 75 percentile of the data, and anything outside of this line are the outliers, right? So now one observation that you can quickly make is the mean value, right? That is the 50 percentile of the data, right? Which is this. The mean value, the average transaction amount is higher in the fraud case compared to the non-fraud transactions, right? So the y-axis represents the transaction amount in dollars, and for the non-fraud case, the transaction, the average transaction value is probably less than 100, right? But on the other side, for the fraud case, the average transaction value is close to $200, right? So this itself gives a clear distinction of what are some of the patterns that you can have in the data set, right? Is there a question? Okay, let's go a little bit complex. So whatever we have seen is more of like a single plot, or we call it as univariate plot, right? It's just one variable. Transaction amount is the one single variable, and we have seen a pattern in that plot. Now let's go a little deeper. We just have a bivariate plot, right, where we have two different variables and then trying to see its interaction, right? Look into this, right? In x-axis we have transaction amount, in y-axis we have transaction amount, and in x-axis we have hours of the transaction, right? In a day we have 24 hours, right? And all this horizontal line represents 24 hours of the day, right? 0 hour meaning that is 12 a.m., 1 a.m., all the way to 12 p.m., right? And y-axis represents the amount that has been transacted, and we also introducing the third variable, which is the label, whether that particular transaction is fraud or not, right? By color coding that. The red ones represents the fraud transaction, and the green one represents the non-fraud cases, right? What is the observation you make here? So again, this is every dot here represents the transactions, right? So how many transactions we have? We have around 10,000 transactions. So there will be 10,000 dots here in the plot, right? So don't have to count that. You have to believe me. But what is your inference? What do you infer? Okay, maybe we'll go. So as you can see, right, the V hours, that is early morning hours, maybe between 12 a.m. to all the way to 6 a.m. right? There is lot of frauds occurring, right? And then the fraud value is also higher, right, from the y-axis here, right? So what does that represents? See, again, take it personally. You are the customer. What is the normal time you transact? You can look into your transaction history, maybe from Google Pay, Phone Pay, right? If you again draw a bell curve in terms of so we draw a bell curve in terms of the transaction value, right? If you draw again bell curve in terms of the transaction time, right? Most of the transaction would be occurring in the daytime, right? Or max to max, between, let's say 7 a.m. to all the way to 9 or 8 p.m. right? Within that period, probably within that 14-15 hours is our prime transaction time, right? Outside of this, we might do maybe in some exception cases, but we rarely do any transactions outside of these hours, right? So now again, what does this say? If any transaction happens outside of this window, and if the transaction value is higher, then that might be suspicious, right? I'm not saying it will always be a fraud. There could be an emergency, right? But just going with these two features, right? A transaction of happening, let's say 2 a.m. in the night, midnight, right? And then a value of, let's say 10 lakh, right? 2 a.m. in 10 lakh is quite suspicious, right? Just with two variables, we can tell whether it is a suspicious or not, right? So that is what we can observe. That is where financial institutions are coming from by looking into the data. Again, whatever we have seen is just the tip of the iceberg, right? In real world, it will not be as easy as this. As I mentioned, this is a toy data. So I just wanted to give you an experience of how financial institutions work. But in real world, there will be a lot of features. Let's say average amount, the transaction value, whether the card was declined in the past. Let's say if your account has been hacked, or not even hacked, right? Let's say someone sitting in let's say a different place in the world and tries to hack, right? Probably they might have tried entering different OTPs. Let's say they might have entered 10 times they might have entered OTPs, and all the 10 times they might have their transaction might have declined because their OTP the OTP is a wrong OTP, right? Let's say 11th time they succeeded, right? They entered a right OTP. Somehow they hacked your phone, or somewhere by luck they got a right OTP and then they entered it, right? Now that number of times the card was declined could also be a feature, right? Because as a customer, you are not expected to have so much decline, right? Now let's say there is 10 declines, right? And then you are transacting 10 lakh rupees, that too in 3 a.m. Midnight, right? So all these things would add up, right? So more and more evidence you have, it's help you to help the model to make a better decision, right? So that's where you need lot of features, right? Number of declines, number of falling transactions, whether it is a high risk country, right? So again, these are very few transactions, probably 10, 12 features that I have mentioned. But in real world, there will be hundreds of features that will be deployed, and then a model will be actively looking into those 100 features for tens and millions of transactions to make a decision. Yeah. Any questions so far? Okay. If no questions, Shenba ma'am, like I have 30 more minutes, right?
Yes, Abdul Sadiq. Yes, Abdul Sadiq. 30 more
Okay,
minutes.
Okay, yeah. Probably I wanted to share another use case from the same financial domain. Let me just start.
If possible, you can share your real-time experience also in your company. What are the data sets you are using? If it is possible for you, what kind of analysis you are doing, how you are helping in the cyber forensics department, like that kind of the things you can also share at the end of your session.
Yes. See, it's a good point because I'm coming from the industry. Probably wanted to know specific cases, but again, right? Like due to security reasons, right? Like we cannot expose a lot of things, and that's where I am, going back to the toy data set. But whatever data that we are seeing, right? So directionally, those are the features that predominantly any industries would use to identify frauds, right? And as I mentioned, the number of failed transactions. The question might be, it's not about training the model, right? The main challenge, if you want me to talk about the real life example, then it comes around the challenge in building these models, right? The challenge would be is in acquiring data, right? How do we acquire the failed transaction data, right? So there would be authentication data sets, right? So that will tell whether, when did the customer logged in, how many times the password failed, right? So those are the cases that would come into picture. And then we would also have certain data like what we call it as proxy data set. So where it would give us, what is the device, the name of the device, the, what is the, browser the companies, the customer has been using, and, what is the country from where the IP address is coming, right? So these are the normal data set that, any financial institutions would use to fuel that model, to enrich the model and then make a better predictions. That is from the fraud cases. The other case is credit risk assessment, right? As I mentioned, this comes under again taking intelligent decision, right, at scale. What is credit risk assessment, right? So credit risk assessment, we saw one use case of AI where it detects, identifies frauds, looks into the patterns, analyzes large volumes of data, looks into the historical behavior, right, and then helps take a decision. This is also a similar case where AI would be implemented, but for the different use case, right? The implementation would be same, like the core concept of AI is same, right? Analyze the data, detect pattern, learn from the historical behavior, and then take a decision, right? So that is the core. But implementation would be, the use case, there are a lot of use cases in financial institution. One we saw is the fraud detection. The other is what we are going to see is credit risk. So credit risk is where, as I mentioned, right, like there are banks which would offer you loan, right? So let's say you are approaching a bank, right? You want to buy a house for you, right? And you are approaching a bank and you want to get a loan from that bank. What are the things the bank would look, right? They can't just give the loan, right? Because they want to know how likely that you would repay that loan, right? If you don't repay the loan, then what happened? It's going to be the loss for the bank, right? But they can't just keep rejecting people, right? Why can't they reject the people? Why can't they keep just reject the loan applicant? Because that is the business of the bank, right? The core business of the bank or any lending institution is to lend the money, right? If they keep rejecting the people, then they can't grow, they can't earn, right? So then it has to be a balance, right? So they can't keep rejecting people, and also they can't keep lending money to everyone who applies, right? So how do they take a decision? Again, there's a lot of dependent values, dependent features comes into picture. You might have heard about CIBIL score. Once you apply for loan, your credit worthiness, that is your CIBIL score, will be reviewed. What are the other loans that you have? Those things would be reviewed. What are your spending patterns? That could also be reviewed. What is your earning potential, right? And what is the value of probably, let's say, if in this case you want to go to a home, then probably they will look into what is the value of that property, right? So depending upon what kind of loan you look, they would look into various factors, right, to whether to apply or not, whether to approve your loan or not, right? Again, there are several advantages, right? Like one is you can fasten this overall process. You can reduce the cost, because again, having a human in the loop is quite costlier, and humans can be biased, right? They can look into, okay, probably he is an maybe some kind of a low wage customer, so he might have a bias in mind that, okay, he is not likely to repay the loan, so let's not give the loan, right? So we might have very limited time, very limited knowledge, right? And because of that limited capability, we might not able to see the whole picture of that loan applicant, right? That's where AI would come into picture and then help us to improve that decision. And again, when we say improve the decision, right, it's not always going to be that a person will be replaced by a human. That's not going to be the case. AI in real-time application, at least what I have seen, it's mostly about supplementing the decision, right? So there will still going to be a underwriter. There will be still some human is going to sit and take a decision whether to, let's say you apply a loan to a bank. It's not that a machine will review your application and then just reject or apply, right? Still a human will review your application, right? But he is not just going to go all the details by himself. That's where AI will come into picture and probably give its decision, right? Probably it will tell, okay, this applicant is high likely to repay their loan, so we are good to approve. Then that person or whoever is sitting behind the screen would review only certain things, would just look into whether AI had reviewed everything correctly or not, right? So it will fasten up the process and then take more information, right? It's more of like supplementing the decision, not just completely replacing or automating the decision, right? We have not reached that level because even AI are prone to do mistakes, right? So we wanted to have better systems, but there are still a lot of mistakes AI still does, right? And we need some accountability on decision making, on every decisions that the institution takes, right? One quick demo, probably in this case, I wanted to give a demo on a machine learning model itself, not just stop with the use case. Let me share the screen. Yeah. I hope you can see this credit risk EDA screen. Interest of time, I will not go deep into EDA, but I will go into probably the models, right? So credit risk, again, as I mentioned, you apply a loan, based on certain features, the bank will tell whether to approve or reject your loan, right? So this is again another data set where we have a lot of features like gender, the age, whether some financial background, whether you have a car, you have a house, the number of children, what is your income, what is your employment status, right? What is your occupation, right? So there's a lot of, and of course there's a credit score, let's say something like a credit CIBIL score, right? So once you have this data set, right, like we saw EDA, right? The other thing we would do is feature engineering, right? After EDA, there will be a lot of feature engineering. in machine learning, right? When we say machine learning, machine only knows to process numbers, right? It cannot process, characters or strings, right? In that case, what we have to do is we have to see if you want to make someone to learn something, then you have to talk into the language that they can understand, right? So for machine only understands numbers, right? So how do we then, in real world, not all data are numbers, right? Let's say in this case you have certain category features, right? Something like okay, if you look into this case, occupation is one of the category, right? What is the role of your job, or where you are working, whether you are a manager, you are a laborer, you are a teacher, staff, right? So these are categorical or non-numerical values, right? And then you also have gender, male, female, others, right? So these are gender. Again, this is not a numerical value, right? Then how do we feed this data, right? So two ways to go about it. Either you drop this data, whether you drop this gender, occupation, right? That means you are kind of restricting your data, right? Kind of restricting your information to the model, right? What if those features have lot of information, right? But then how do you give it? Then you have to do some transformations, like you have to do dummy coding, right? I'm skipping this null and nil. Probably I'm guessing you already know those things. Dummy coding, like you have to convert these into certain values like zeros or ones, right? Like probably if it is if you own a car, then you can dummy code it as 0. If you don't own a, if you don't own a car, you can dummy code it as 0, no's as 0, and yes as 1, right? So that could be of dummy coding. And then there are features like what kind of occupations you have. Then that can also be dummy coded. You might have already know what are the ways we can fill in those features. But let's look into those, right? The core concept is to make a model, again, learn from the past experience, right? Whether a given applicant would default or not, right? Whether to give loan to them or not, right? Now, how do model will make decision? Again, it will take learn from the past experience, right? Now, again, look into this case, right? We have in this data set, we have a lot of applications, details about the applicants, right? As whether their occupation, their age, and again, the target variable is whether they have defaulted or not in the past, right? This is again other way of looking into the distribution. Earlier in the fraud case, we saw a account plot. Here we are seeing the pie chart, where we are seeing there is 90% or 92% of the applicants have not defaulted. Only around 8% of defaulted, right? Again, this is how the real world use case would also be. Not major applicants or major customers would not default. There's small amount of people that customers would default. Now, the bank would be very happy to give loan to these people, this 92% of these applicants, rather than this 8%, because this 8% are very likely to default, right? But the problem is the bank would know beforehand whether they would default or not, right? So this data we have because they have defaulted. Bank has already given them loan, and this 8% have defaulted, right? Now, in future, bank wants to know, can it do a better job in identifying people who are likely to fraud default, right? So one way is looking into, again, EDA, right? What you have seen is age wise, we don't see much distribution, but as people tend to age, probably after the 50s, then there's a lot of people that are likely to ask for loan and then default. And the other case, again, this is this is again coming from data set taken from website. I will probably give you the link to this data set. Okay, this is another, again, a box plot, interesting box plot, where we can see in the y-axis we have the credit score and x-axis we have the whether it is a fraudulent or not. What do you see here is in the credit score basically represents your credit worthiness, right? I think there are a lot of factors goes into picture, something like how many loans you have borrowed, how you are repaying that loan, right? How is your financial health basically, right? And what you have seen is people who have not defaulted, right, which is zero, right? People who have not defaulted have a very high average credit score, right? Close to average is this, the center line, which is close to 800, right? Credit score was close to 800, whereas people who have defaulted have very low credit score, right? Relatively low credit score, which is close to 600, right? So credit score, if someone, let's say in future, if there is an applicant who is coming with a very low credit score, then that means there's very likely to, highly likely to defraud, right? And then there is this another plot that says your credit limit used. So there is always this 100% of credit limit, right? Like let's say person A can maybe have a credit limit of 10 lakh, right? But person B might have only credit limit of maybe 2 lakh. There's a lot of factors goes into picture. It depends upon his net worth, depends upon his income, right? So this talks about what is the usage of the credit limit, right? So people who have defaulted would always are more likely to exhaust that credit limit, right? Always on the upper boundary of that credit limit, more than 80%, right? Whereas people who don't default are, well within their credit limit range, right? So yeah, probably I will skip these things. These are more of like an EDA, which we have already seen in that fraud case. Quickly jumping into the model, right? Again, what kind of models you can build? So this is a classification model, right? Meaning there is a customer coming with an application, loan application, and all the model has to do is whether it should reject or approve, right? Rejection and approval is what the model has to take a decision, right? And we have seen what are the features that it will review to take the decision, and it will always learn from the past experience of people who have fraud defaulted. And again, this is a binary classification because there are only two possible ways you can classify. So when we talk about binary classification, there are tons of classification models. But most out of all the models, right, based on my experience, again coming from industry practices, what I have built and what I have seen from my other fellow data scientists would have built, if it is a tabular data set, when we say tabular data set, the data set that contains rows and columns, right? If it is a tabular data set, and if it is a classification problem, right, meaning it has to take a decision whether it is yes or no, right? Then most out of all the models you have seen, like decision tree, random forest, right? You have SVM, KNN. Out of all the models, most of the time what I have seen is XGBoost is it could be a life-saving model which would have outperformed the other models. That is kind of an right now a more advanced model. I would say even compared to neural network model or any AI based models, XGBoost would be performing better. You can use AI or artificial neural network models. Let's say if you have unstructured data, right? So this is a structured data, tabular data. Unstructured data is something like you have image, you have audio, video. So those or even LLMs, right? So text. So for those cases, neural network model would be performing better. But let's say if we have tabular data, then XGBoost, I would recommend XGBoost would be the first choice of selection, right? Yeah, so how do we go about model? Like, let's say we select a model, we do cross validation to identify the parameters. We create, we fit the model, we fit the data on that model, and then train the model. Again, this is a composition of different models, performance of different models, and precision, recall, F1 score. This will tell how good or how bad the model is, right? We compare it with the ground truth because we already know what are the cases customers have, in which cases the customers have defrauded, and we want the model to predict whether the given features, whether that customer would fraud or not, and then we will compare it with our ground truth, whether the model did a correct prediction or not, right? So that is more of what we do in terms of identifying the performance of the model and then selecting the best model that we want to use. Any questions? Anything you want to gain more insights about the modeling? Okay, quickly, like there are other things like in terms of automating repetitive tasks. You would have seen, probably I'm not sure, like Zerodha is a popular, financial institution where it helps us to do financial marketing stuffs like buying shares, selling, mutual funds and all those stuffs. And they have this AI in the backend, right? In terms of onboarding, right? Let's say if you want to open a bank account or a demat account, then you have to visit that branch and then you have to give the document and then you have to do the basically the KYC stuff, like know your customer, right? But Zerodha, what they did is they used AI to do that, automate that KYC process, right? How do they do? They would send you a OTP code to your registered phone number. All you have to do is write that phone number and then take a selfie, right, in front of the camera with your face, right? So now where AI has been using here, so there are two ways, right? So behind the screen, AI has been used here to validate or match your photo with the other photo that you have already uploaded, right? Again, it's not human that is matching the photo. Imagine like we have Zyada easily might have millions of customers on their platform. Imagine there is a team that would be matching between these two photos, right? So it's going to be very tiring tasks, right? So there is AI behind the screen which would be trained on images like artificial neural networks that would know how to identify similarities between two photos, right? So photo one will be your other photo, photo two will be the selfie photo that you have chosen, and they would have trained the model to identify pattern in those images. Of course, I know most of us will not look same as how we look into the other photo, but assuming that they would have trained the model with that kind of scenarios, neglecting the edge cases, right? And the second part is the the numbers, the OTPs, right? Again, Zerodha know what is the OTP sent to that particular customer, right? And now they have the image, right? Which also has the OTP, right? In this case, 7686 is the OTP. You might have heard, heard about this handwritten digit recognition data set, right? That is the exact use case here, right? This is a handwritten digit. Zerodha has to first build a model that would recognize these handwritten digits, right? See, for the human, it's easy, right? For me, if I ask, I can tell both the persons are same, both the numbers are same, right? But you need something other than a human that would automatically say whether, okay, there is a match between these photos and these numbers, right? That's where AI comes into picture. It will look into this, particular box, bounding box, and then, identify this number and then match it with the OTP, right? So again, that is the other case. Chatbot, again, probably you already know with the rise of LLMs, the advantages like you have 24/7 support and there's a lot of personalization happening. Yeah, future trends, see, one thing common, again, coming from the industry, since Shinba ma'am asked about industry, that's why I'm going towards that. Training model, it's easy, if you have data, right? So, but how are one question is be like, let's say if your application for loan is rejected, right? You want to know why it is rejected, right? Even the lending institution want to know the reason behind its rejection, right? It needs to be explainable, right? It's not just needs to be predictable, right? Predicting yes or no, it's easy, right? You just build a model. I just went through within seconds, right? You have an XGBoost model from sklearn, and then you fit the data, you fit the model, the data, and then get the prediction, right? But the model also needs to explain why it took a decision, right? That way we can able to verify whether, okay, it took a decision because let's say the credit worthiness, the credit CIBIL score is low, they are into, their income is also low, they are like from a low income group people, some kind of things, right? So if these explanation has to become, and this is what industry is also looking forward to, gain more insights on every decision that it takes. Yeah, probably with this, I will stop my session. I know we are running out of time here. Once again, thanks for listening in. Let me know if you have any questions or any doubts you want me to clarify. I can stay probably for the next few minutes.
Participants, if you have any query, you can interact with the resource person now.
It's available to finished started at
I couldn't get it, but I guess, yeah, I guess you're asking about the code, right? Because I didn't walk you through much in the detail. Is that right?
Yes, sir.
Yes. I will, ma'am, like probably, I don't know, like I can share you those notebooks and the presentation. Maybe you can pass it along with the students. Yeah, I actually wanted to go in detail, but I just wanted to cover the high level topics. But yeah, maybe I can share you the code. Feel free to reach me out if you have any queries. We can discuss offline as well.
Sir?
Yes.
Sir, while we were discussing your final future trends, when we want to convert into the top of our explainable AI, what are all the other techniques we have to incorporate in with respect to the existing deep learning models? So we have classification, categorization, and regression. Apart from it, what we want to add to make the model very decisive, sir?
Yes, ma'am. That's a very pointed question. Yes, I mean, that's okay. First thing is, it's an ongoing research. There is a lot of scope. There is no, constant answer saying that, okay, this is the one way. So as you mentioned, rightly put it, if it is a classification model, then you can go with certain algorithms. If it is a regression model, then you can go with different algorithms. But how to make a model more explainable, it's an ongoing research. But there are a lot of new things came in, right? So we have seen XGBoost. There is a new algorithm that is being built by Google called explainable gradient boosting, right? So the algorithm not only predicts, but it also explains its decision, right? You can Google it. I will probably share you that link. See, one challenge with the model is you might have looked into the popular plot that would say more complex the model, less interpret it becomes, right? So by that, if you have a decision tree, right? If you build a decision tree, it's very easy to interpret the results, right? It's just a tree. It's a biportrait tree. If this
like a hierarchical tree like structure.
Exactly. Right. But the problem with decision tree is it won't be sufficient, right? The performance
if the performance fails, then we have to go with the other node for taking the decisions again.
Right, and even the overall performance of the decision tree compared to something like a very sophisticated algorithm, let's say deep learning models, right?
Yes.
Deep learning models can easily outperform decision tree in terms of the prediction, the performance of the prediction. But the challenge with deep learning models, it's very difficult to explain the model why it took the decision, right? Because in deep learning, there's a lot of layers. Model tries to understand the data from its point, which would be very difficult for us to interpret, right? So there is, as I mentioned, there's an explainable boosting algorithm that is currently in trend, and there are something like Lime, Shapley. So these are certain techniques that you can implement that would use something called as game theory. Some of us would know in operation research there is something called game theory. So with this game theory, they would try to explain how does this model give this score to this transaction or that particular observation based on the feature. So it will tell which feature, which value, what value of that feature help the model to give that score, right, or make the decision. So it will give that plot.
Thank you, sir. So again, we have to go for more iterations for building a successive model.
Yes, it is. It is, and again, even with Shapley values, it's not very straightforward to connect with business. See, for data scientists or for practitioners, they can understand Shapley values, but again, we have to translate that to a business person, right? In this case, bank or the financial institutions. So, how to translate that, right? So that is still an ongoing, and there's a lot of innovative methods which can be explored. So that's a interesting space. That's why I have put it in the future trends.
Thank you,
But
sir.
good question, ma'am.
Thank you.
Thank you, participants. Thank you for your interactive questions to our resource person. Now it's my time to thank Mr. Abdul Sadiq, Senior Data Scientist at Fidelity Investments and a Certified AI Practitioner. He delivered an excellent session on AI-driven decision making, leveraging data science in financial services. He provided insightful analysis on fraudulent activities using a real-time data set. His explanation of machine learning fundamentals and the use of various visualization techniques, including bar plot, box plot, and distribution plots for data inference, was exceptionally well presented and highly engaging. Additionally, his discussion on automatic repetitive tasks was clear and highly informative. And the way he answered our query was very nice. Thank you, Abdul Sadiq. Thank you for your valuable time and valuable knowledge sharing session to the participants. Thank you so much.
Yeah, thank you. Thanks again for this.
Thank you so much, sir.
Yeah, thank you. Thanks for listening in. Yeah, hope it was useful.
Thank you, ma'am.
Yep. All the best. Have a great day.
Thank you.
Have a good day, sir.
You too.
Thank you, sir.
Thank you.
Okay, good night.
Share your details, sir.
Thank you,
Sure,
sir.
sure. I will. Yeah, thank you.
Thank you, sir.
Thank you, sir.
Thanks. Good night.
Participants can leave the meeting. We will share the feedback link